All right, we should be good to go. We're live. Hello, hello, everybody. Hope everybody's having a good one. We got people? I don't know what that means. What do you mean we got people? People are streaming in, don't worry. People will come in. And we'll start answering questions as soon as they start getting in. Testing. Okay, the audio is, I don't know why TikTok does this. Sometimes it just says no audio detected. Is dark energy more your field or chemistry? Dark energy is not more, I mean, to some extent dark energy is, you know, tangential to my field, but dark energy is also not chemistry, and that's not the only other option. Oh yeah, community gift. Is it already set? Is community gift? I don't have to do anything for that, right? Is phantom dark energy observed? Well, look, we don't know what dark energy is. If it might be a phantom dark energy though. Hope you're well. Yeah, I'm doing okay. I might be a little hungry though. Oops. Oopsie poopsie. What if we are the aliens? Well, we are the aliens to other... We are the aliens to aliens. Why do you call yourself doctor? Because I have a PhD in physics, and that's a doctorate degree. Hey, but is fire on things or are things on fire? I would say things are on fire. What is dark matter made of? We don't know. Does thermodynamics explain the arrow of time? Not sure about if it explains the arrow of time. Maybe it accounts for the arrow of time. Can you turn your mic up a little bit? I can adjust that on my end. It should be good though. Maybe I just brought it closer, so that helps. You were still salty about the Big And theory? I don't know what the Big And theory is supposed to be. Is the CMB and Hubble's law empirical evidence of Big Bang expansion? Yeah. In the future, super chats will include sending food that materializes in front of you, if only, right? Do you learn more at a top college than an average college? Debatable. It's possible that you do, but it's probably not significant. Okay. You're going to learn more at a top college than you will at like a bottom college. Lol. But an average college will probably have a pretty good curriculum compared to a top university. However, you will have more opportunities if you go to a top university. Can you explain the 4D and how it is time? Well, look, a dimension is just or the number of dimensions that a space or that like a thing has is how many numbers you need to describe where you are in that thing. And if we're talking about space-time, then in order to specify where you are in space-time, you need 4 numbers. Your 3 numbers for location, and then 1 number for when. Do you think time is fundamental, or is it possible it does not exist in quantum mechanics? I'm not sure. I was watching Dean earlier, and he said you were watching. Yeah, well, that was yesterday. But yeah, I have, if nobody else is on, usually I have Dean or Parker on in the background when I'm working. So we have empirical evidence for the BGV theorem. The BGV theorem is not the kind of thing that you can have empirical evidence for. It's a mathematical theorem. It's also like underspecified, so... What is the difference between dark matter and antimatter? Dark matter is matter that we can't see that has mass. Antimatter is just like regular matter, but opposite. So if a regular matter electron has negative charge, an antimatter electron has positive charge, but we can still see it, no problem. Do you think that the Big Bang could have been the death of the previous universe that collapsed? Maybe. Thoughts on string theory being a red herring to hold back actual advances in physics? No, that's false. String theory is a genuine effort to try to better understand the world around us. When I tap the spoon on a cup of coffee I just stirred, the pitch of the sound goes up. What's going on here? I've heard about this. I think it's related to the viscosity of water changing with temperature. This is why pouring hot water will sound different than pouring cold water out of a sink. And I suspect it's the same thing that's happening with the spoon in a coffee cup. Where are these bottom colleges asking for science? San Francisco? I joke, of course. I hope that wasn't too far. Could you please explain what spin is? Spin is just an intrinsic property of matter. So we think of matter having certain intrinsic properties like charge. And, you know, in principle, mass could be an intrinsic property. And spin is just another one. So there's charge, which is how it interacts with the electromagnetic force. There's mass, which is how it interacts inertially, or how it reacts inertially. There's spin, which is how it interacts with torques, or which will tell you about how it interacts with torques and angular momentum. So like, it's just an intrinsic property of a thing. If you buy a thermal camera and find any humanoids lacking heat signs, it's a vampire. Ah, fair point. It's hard to listen to colors on Parker's lives. They're so bad that it hurts to imagine it's real. Yeah, I'm with you on that. CMB and Hubble's law is evidence for average expansion, little nice reality denial. No. So CMB and Hubble's law are definitely evidence for average expansion, but they're not evidence for the BGV theorem. The BGV theorem is not the kind of thing that requires empirical evidence. The BGV theorem is a mathematical theorem. Now, whether or not that mathematical theorem is relevant for a universe, that's the kind of thing that requires empirical evidence, because you would need to show that our universe satisfies the hypotheses. That's an empirical claim, but the theorem itself is not empirical in any sense of the word. Are all strings the same in string theory? Well, in string theory, you have open and closed strings, and that's it. So these are strings that loop on themselves and strings that don't. Do you eat pork and shrimp? I don't really eat pork. I do eat bacon, but I don't really like pork, like, you know, other pork cuts, and I don't eat much shrimp, but that's just because I don't really love pork, and I don't love seafood. Should we be prioritizing manned space missions over unmanned landers, telescopes, probes, etc.? No, I don't think so. Do thermodynamics change in different parts of the universe? No. What do you think about the growing entropy of the universe? It's hard to say that the universe even has a well-defined entropy, because entropy is really tricky to define when you include gravity. Any universe that has been expanding on average cannot be past eternal. Well, that's like a lay description of the BGV theorem, but the BGV theorem, in fact, kind of assumes that that's true. It assumes that the average expansion is non-divergent, which is a problem for the BGV theorem, right? Like it's an ill-posed theorem as written, as originally written. From JJ Masta with the £5. Thank you so much, JJ Masta. Would you rather experimentally solve quantum gravity, dark energy, or matter, or figure out the correct interpretation of quantum mechanics? The former, definitely the former. What specifically is preventing the existence of a time machine? Probably things like the lack of matter with negative mass. Oh, I forgot. I'm supposed to dab when I do that now. All right, I'm going to jump to the bottom because I'm like way behind. But thank you guys so much for asking all these good questions. How do you feel about job market for STEM PhDs like engineering and physics? Are they worth it? Probably. Well, okay. The job market for PhDs is always hard. The reality is if you get a PhD in engineering, it's not necessarily going to help you that much more than a master's. And a PhD in physics is not going to help you get a degree or a job in physics unless you're going to work at a university. And though the job market for that is very, very hard. Do you know anything about the monster group and group theory? Only that it is the largest sporadic group. You still believe in the heliocentric model? Yeah, we have good empirical evidence that not only the heliocentric model, but like the entirety of cosmology and astrophysics is true. How much have we measured the energy production of virtual particles? It's not clear that virtual particles even exist, so. We have empirical evidence it's expanding on average. Well, we have empirical evidence that it has been expanding on average since about 13.8 billion years ago. But seriously, Matt Davis, just go read the paper by Eason. It's by Eason, Davies, and one other person. And you'll see that the criticisms of the BGV theorem are reasonable. And don't just shove it into ChatGPT, please. Oh, what type of experiments do scientists do to catch or detect dark energy or matter? So there are a lot of experiments that are being worked on or being built to try to detect it, but we haven't successfully detected those things yet. So for dark matter, basically we build there are kind of two ways that you can try to do this. You can either try to make dark matter in a like a hadron collider, or in a particle accelerator, like the Large Hadron Collider. The other thing that you can do is you can just build a giant tank of water, essentially, or a giant tank of something, and then try to understand, and then try to basically detect the random interactions, the random low probability interactions between whatever dark matter is and the stuff that you have, the stuff that you're watching very carefully and very, very precisely. As far as dark energy is concerned, dark energy is probably not a stuff. It's probably like a property of like a field of some kind, and so we can only see the effects of dark energy. From JJ Masta with the £5, you'd easily pick quantum gravity over the others. Why the preference? Oh, I'm sorry, I misunderstood. I thought it was quantum gravity, dark energy, or matter, or figure out the correct interpretation of quantum mechanics. I still would choose quantum gravity because I suspect once you understand quantum gravity, then you'll understand much of the others. But yeah, I did misunderstand the original question. Is there a finite amount of energy in the universe? And more importantly, how long can I run my Xbox on it? We don't know if there's a finite amount of energy in the universe. How do you view Graham Oppy as a cosmologist rather than as a philosopher? I don't think he is a cosmologist. Let's jump down to the bottom so I don't miss more. Can you explain the double slit experiment? Yes, I do have a recent video on it if you want to check it out. It went kind of viral, so I'm surprised that not everybody saw it. But the double slit experiment is best accounted for. So the thing that needs explaining is why things behave like why things have wave interference in one case and they don't have wave interference in another case. And so all of these things are going to have wave interference kind of by default. But if you then interact with them, they can no longer interfere because by interacting with them, you're changing the kind of state quantum state that the thing is in. That's the main issue, and things can only interfere if they're in the same kind of quantum state. Where did the original matter come from before the Big Bang? How can something always exist? Well, if the question is where did something come from, then as in, it doesn't seem like it could have come from nothing, then it seems like it must have always existed. What's a gravitational wave detector telescope? Does it have 2D resolution pixels? So it's not a literal telescope. So the way that we build gravitational wave detectors that can directionally detect where they come from is by essentially building giant L-shaped lasers, and we put them in several places so we can triangulate where the gravitational waves come from. And those lasers detect the gravitational waves as they pass on by. From Mockingbird Dan with the $2, universe expand in discrete distance Planck length? The universe isn't expanding like the edges are getting further away from each other. There likely are no edges to our universe. Rather, each volume is just occupying more space as time goes on. And it's not clear that Planck lengths are units of discrete space. Why do fermions and bosons have different spins? Well, that's what a fermion and a boson are. They're two different things with different spins. What do you think of causal dynamical triangulation? I'm not so knowledgeable on it, but it is definitely interesting. The BGV is mathematically proven and fits the description of your universe, and I read that paper. Oh no, it's not mathematically proven, not in the original paper. And if you had read the paper, then you would know that it's not mathematically proven because it's not even well posed. What's the most plausible theory for an eternal universe? Most plausible? It just, I mean, like, I don't know if there is one that's most plausible. There's a lot of options, and I would say probably none of them are over 50% right now, because there's so many options. I feel embarrassed to ask, but what is a physicist? Yeah, a physicist is the kind of scientist that like Albert Einstein was, if that helps. I don't believe in Newton's laws. Can I defy gravity? Unfortunately, no. Let's jump down to the bottom again. How's the rotation of planets and stars slow down? So, generally speaking, angular momentum is conserved. However, there are some ways to prevent the angular momentum of a single object from being conserved. For example, the Earth's rotation is slowing down because the moon is pulling on it in a differential way. So the tides, the moon causes the tides primarily. Those tides are basically trying to follow the moon, but there's friction between the water, say, and the ground that they're flowing over, like the Earth that they're flowing over. And so that friction slows down the Earth ever so slightly. And so the moon's effect on the Earth to produce tides is slowing down the Earth until eventually, if the moon wasn't also leaving, eventually the Earth would become tidally locked with the moon, and the same side of the moon would face the Earth at all times. Or the same side of the Earth would face the moon at all times. They would both take 28 or however many days it is to go around to make one full rotation. What is loop quantum gravity? So loop quantum gravity is just a different approach to solving the problem of how we quantize gravity than string theory, and it's probably the second most popular one. I probably can't go into the details because I don't understand them well enough, but the important distinction between string theory and loop quantum gravity is that string theory purports to be a theory of everything. Loop quantum gravity is just a theory of gravity that's quantum. It doesn't purport to unify everything. It's just a theory of quantum gravity. If observing a quantum entangled particle breaks quantum entanglement, then how do we use it in computing? Because you don't have to observe it. Observe means measure until you're done with the computation. And then it'll be in the state that you need it to be from the computation. Can you speak Czech? No. How can we tell that the sun orbits the galactic center? I don't know if you mean empirically or if we mean like model theoretically or what you mean, but what we do know is that gravity is universal. We can see this in other galaxies. And so if gravity is universal and we live in the universe, then the sun's motion through the solar system, we can also, by the way, measure our relative speed to various things in the solar system, or sorry, in the galaxy. And so from there, we can infer that the solar system is going around the galaxy. What does a physicist actually do during the day for their 9 to 5? What does their actual work look like? Is it mostly on paper, on a computer? Is it mostly math? It depends on what kind of physics you do. It depends on where you work, what kind of institution you work at. If you work at a university, your day-to-day is going to look like, depending on where you teach, and yeah, depending on where you teach and how much grant money you have, it'll usually look like teaching 1 or 2 classes a week, or 1 or 2 courses a week. So that would be like, you know, teaching either 2 to 4 1.5 lectures a week, or 3 to 6 50-minute lectures a week. Then there's obviously going to be some administrative duties, but you're going to spend probably 60% of your time working on research. Now, if you're a theorist or a computational physicist, then you're going to spend most of your time either on paper or on the computer. If you're an experimentalist, you might spend a lot of your time on the computer doing simulations, or you might actually spend some time building things specifically to run your experiment. From JJ Masta with the £2, thank you so much. What one law of nature would you change or remove? I don't know. I like the universe the way it is. The universe is nice. I don't know. That's a hard one. Maybe I would remove the matter-antimatter imbalance. No, that'd be bad. Maybe I would somehow remove the instability that would be implied by the existence of negative mass matter, so that negative mass matter could exist. but that would change everything. So by the way, remember, if you want your questions to be answered with like guaranteed, then feel free to send a super chat. They do get first dibs, as I mentioned. Otherwise, I will try to get to all of your questions if I can. The original BGV theorem is mathematically proven. It's well-established result in cosmology. Well, if it was mathematically proven, then it wouldn't be vague, and the paper that you read wouldn't have established that it's sufficiently vague that it's ill-posed, and that it sort of begs the question. Are you a cosmologist? Not full-time. I don't spend all of my time on cosmology, but I spend some of my time on cosmology. Do you count your social media work under service in your academic file? Yeah, you could say that. What got you interested in learning physics? I saw renderings of black holes when I was like 9 years old in like the early 2000s. And I thought that was really cool. Did the Big Bang create everything in the universe or just expose everything in the universe? I don't think either are true. No, Matt Davids, the debate is not about what geodesic passing completeness means for the universe. That's not what it means. That's not the debate. And I understand that you don't know this because you don't actually know physics, but the debate is not about what past incompleteness means. No, the theorem itself is not mathematically sound. Not as phrased originally. We did just get a $25 super chat from somebody, and for some reason I can't view it. Oh, from Rob. Thank you so much, Rob. Does quantum gravity require quantized spacetime? Do gravitons remove quantized spacetime requirement? Quantum gravity doesn't necessarily require quantized spacetime, no. And gravitons also don't remove quantized spacetime requirement, no. What should I direct my scientific learning inference model to attempt to solve in physics? I don't know, whatever problems you're interested in. I've ever debated someone that is worth debating or just debating people who doesn't know a thing? Well, I'd love to debate people worth debating, but they don't often come up on my live streams anymore because I guess the conversations have been had or they just don't want to. I don't know why they don't. I don't know why the people I talk to are always so silly. Are you currently working on a paper? What papers have you written? Well, you can go to my website and see all of the papers that I've written. I'm working on several. Actually, a lot of what I'm working on right now is like doing referee process for a lot of the papers and like, you know, doing that kind of thing. But if you want to see the papers that I've published, you can see all of them. They're all freely available. That you can read them all online. But they're all, and you know, it'll say which ones are published as well. You can just go to my website. It's blitz.phd. There's no .com, just blitz.phd. Go to the research tab, and you can see all the papers, and you can just click on them, and I don't know, it'll take you there. And then you just click on View PDF over on the right. Just View PDF, and bada bing, bada boom, you get a paper. So if you want to see those, you can. I've published, I don't know, more than a dozen papers in the last 6 years. From Git Stanfield with the $5, why is it so difficult to reconcile quantum mechanics and GR? So there are some conceptual issues. The conceptual issues are like, quantum mechanics typically requires something called a time translation generator. This is the thing that, or rather, we would say that time translation is, or what do I want to say? Time translation is generated by the Hamiltonian, but in GR, there's not always a well-defined time translation operator. So it's not clear how you would do that. Like, that's a conceptual issue. There's also issues with, like, typically we think of quantum mechanics as happening like on spacetime and not that spacetime itself is dynamical, so that's tricky. But then there's also technical issues. Like if you wanted to write down a quantum field of gravity, it's not clear, or it's just a fact that it's not renormalizable in the kind of naive sense, which is a problem because we want our theories to be renormalizable, otherwise they're inconsistent. So there are technical issues and conceptual issues, but I take the time issue to be probably the most serious. What is the strongest argument you have heard against one of your opinions in physics? I don't think I have heard any. I mean, I usually don't debate my opinions in physics. Why does Lagrangian mechanics fail for non-conservative forces? Well, try writing down a Lagrangian for a non-conservative system. Try writing down a Lagrangian for an equation of motion that is non-conservative. You'll find they can't. Does Malamud-Manchak mean theorem prove that we can never know if the universe had a beginning within spacetime? Not necessarily. There was a follow-up paper to the Malamud-Manchak theorem, or paper. That was, it was like, let me see if I can pull it up. Where is it? Why can't I find, okay. Okay, yeah, the paper is called Careful with Those Scissors, Eugene, which is very funny, by the way. Yeah, here's the paper. And so this is making the claim that if you grant certain properties of how things form or how things behave in the universe, like if you say that, you know, singularities only form via collapse, for example, if you make reasonable assumptions about how the universe got to the way it is, then this paper claims that actually you can distinguish, you can kind of wriggle your way out of the indistinguishability claims of Malamud-Manchak. So it's debatable. It's certainly not settled science. How do you feel about superdeterminism to bypass Bell's theorem? I don't like it. Can science explain emotions since chemicals do not feel emotions? It depends on what you mean by emotions. If you mean like qualia, then, you know, that's a question for neuroscience, for what qualia even is. If you mean like, can science explain the mechanism behind why we feel certain emotions, then plausibly, yeah. What was the best argument you've heard in favor of a flat Earth? That it looks flat, I guess. Is there a unit for how much space-time bends? Not a unit. You can kind of write it in a few different units, but you might use something like inverse meters, or like inverse meters would be perhaps a reasonable one. But more to the point, we talk about space-time curvature. Are electromagnetic and the weak forces the same or behave the same at high energy? So they are two aspects of the same same broken piece of glass. You can think of it that way. So imagine that you have a single piece of glass. Well, it's one piece of glass, but then if you break it, now you might have two pieces of glass. But they were the same piece of glass. They're just different now because you broke it. From JJ Massa with the 5 pounds again. Thank you so much, JJ Massa. Let's say we confirm the existence of singularities. Your reaction? Huh, that's strange. I wonder how that works. From Cosmic Wide Web with the $2. Is time an illusion or variable in cosmic scales? Neither. Time, I guess it's a variable insofar as it's like an independent variable, meaning that we use it as like an input parameter, but it's not like a thing that like changes willy-nilly, if that's what you're getting at with, you know, the word variable. What do medical physicists do? Medical physicists work with typically what is it called? Not radioactive. Basically, medical physicists work with particle accelerators and CAT scans and things like this to work out dosing properly. So particle accelerators are sometimes used in some cancer treatments. Antimatter is used in some cancer detection methods like PET scans. So medical physicists are the kind of people that like work out dosing and work out the details of like what kind of things are safe, what kind of things would be most effective for whatever treatment or diagnostic they're trying to do, etc. So they kind of do, they're kind of like particle/nuclear physicists with applications to medicine. Can carbon nanotubes get around quantum tunneling if directly touching? I don't know what that question means. Can you explain what quantum dots are to me? No, I don't know what quantum dots are. I've heard the phrase a lot, but that's a condensed matter thing, and I just don't know a lot about condensed matter. Do you think higher dimensional spacetime is the key to unifying GR and quantum mechanics? I don't think so. I mean, maybe it is, but I wouldn't be surprised if it wasn't. What are the chances that we are living in a false vacuum? If you at least trust, you know, the best LHC data that we have, it's like on a razor's edge as to whether or not we are living in a false vacuum or not. Like the data could go either way. And it's like right on the line, which is very weird. How do you feel about entropic gravity? I'm not convinced. I'll put it that much. I'll put it that far. Time has 3 dimensions instead of 1. Well, it seems like it has 1. Do you have any tips in interpreting grouped up terms on Lagrangians? It depends on the system, right? Like it just depends on the system. And like part of physics is doing interpretation of mathematics. So like, not really, no. It's hard to, like, part of physics is like just being able to do that for a given system. And unless you show me what the system is, it'll be hard to say. Is energy something coherent in a timeless state of affairs? Like it won't change amounts, but there's no work to be done? No, not really. And if there's no time, then there's not really a well-defined notion of energy. If gravitational waves are subject to constructive and destructive interference, has it been studied or asked if dark matter is the interaction of gravitational waves at similar amplitudes? So gravitational waves are subject to those, but constructive or destructive interference can't account for dark matter because dark matter seems to behave like stable particles, like just stuff that's not moving very fast. And wave interference doesn't produce systems like that, doesn't produce regions of high amplitude like that for a long time. If you were not doing physics, what other science would you do? Maths excluded? I don't know, maybe geology. Geology is cool. How was antimatter discovered or detected? Well, it was predicted by Dirac when he wrote down the Dirac equation. He's like, huh, maybe there's this extra kind of, maybe the other solutions are not negative time solutions, but instead they're a different kind of stuff. That was roughly the idea anyway. This was predicted, and then it was just discovered. I don't actually know the history of how it was discovered, but it was discovered afterwards. Could physics realistically develop further to directly benefit our lives much? It depends on what you count as directly benefiting your lives. You need perfect grades to be a physicist? No. Why haven't physicists determined whether or not the universe had a beginning? Is this a new concept or is there some missing piece? Well, look, we've only been doing serious cosmology for like 70 years, maybe? That's less than a human lifetime, and you want us to take this brand new science and have solved the oldest question in human understanding? Like, I don't know, man. Maybe you're asking a little bit much. Maybe it's a hard question. Would B theory of time more accurately be called a hypothesis than a theory? No. Theory here is used to refer to a framework or like a model. Would you debate Dean Withers? I mean, sure, but we don't disagree on that much. He's probably more of a capitalist than I am, but like, morally speaking, we're probably on the same page. I just think that we should actually like put in the work to change things, whereas, I don't know. Why do physicists find singularities fishy? Because there's signs that the math doesn't work. And physicists are used to math being able to describe things that exist. And so if we can't describe this thing that supposedly exists, that's fishy. How do we know there's dark energy and dark matter if we can't observe it? So we know that there's dark matter because we can indirectly observe it. We can map out exactly where it is based off of its gravitational influence. Dark energy is a little bit harder. Dark energy is inferred to exist. Namely, we see this effect and we're like, okay, well, whatever is causing the effect, we're going to call that dark energy. Is it possible space vacuum is the sucking pressure from dimensions of space we can't detect yet? Space vacuum isn't a sucking pressure. Hey, double slit experiment, what's up with that? How does it change based on observation? I made a video on this recently and I answered it like 20 minutes ago. But the gist is that by interacting with the system, you are affecting the system. And of course, if you affect the system, it can behave differently. Have you heard any recent news in string theory? Nope. If time is relative, is the future already determined? Some would argue yes. From Chase Martin with $5, infinities are the universe's way of telling you your theory is incomplete. Yeah, that's my view. From Cherry Bomb Games with the $5, appreciate you. Also, I recently became a member of my local DSA. Well, that's neat. From Cosmic Wide Web with the $2, what part of quantum mechanics doesn't agree with gravity? So I did answer this like 10 minutes ago, but probably the biggest conceptual problem with quantum mechanics not agreeing with gravity is that quantum mechanics really requires something called a time translation operator. This is like the Hamiltonian. It tells you how your system evolves, how it changes from time to time, how it changes in time. But in GR, this is what gravity is, there's not always a well-defined time translation symmetry. So it's just not clear that like this is a thing that like the standard methods that we use in quantum mechanics can even apply to general relativity. Can dark energy emerge from dynamics beyond our observable universe? Yeah, some people, so this is a view that was popular in the early 2000s. It was called the ekparodic, like an ekparodic universe or ekparodic model, where they kind of took it to be, they kind of took dark energy to be at least partially partially caused by, you know, the fact that our universe is a 4-dimensional spacetime embedded in a 5-dimensional spacetime, and that 5-dimensional spacetime can move around, et cetera, et cetera. It's not quite dark energy, but it's closely related. What's the most popular quantum theory on how particles communicate instantaneously? Particles don't communicate instantaneously. That's the failure to understand. That's the failure to communicate. We travel to Andromeda with the speed of light. Does it take 2.5 million years, or was it minutes? So from the perspective of the person traveling near the speed of light, it will take minutes or hours or however long, depending on how fast they're going. From the perspective of somebody back home, it would have taken them 2.5 million years. From JJ Masta with the £5, again, so generous. JJ, if infinity equals bad, why do we accept that there will always be more time and more space in every direction? So the issue is not just infinity is bad. The issue is kind of measurable or observable infinities. So the idea is that you wouldn't want something that has like infinite density, because that could just be like in a place, and then you would go try to measure its density and it would be infinity, and that would be a problem, because gauges can't read infinity. There's no infinity at the furthest end of a dial, right? But if the universe is infinitely large, that's not like a measurable infinity. You can't go out and like measure the length of an infinitely large universe. You would just find that there's always more that you can measure. And so there's not really an issue as long as the infinity is not the kind of thing that can be like measured in a laboratory. And from Dwabi with the $5, what's the dumbest argument you hear from flat earthers that you hear often and can't believe how dumb you hear it because how dumb it is? I appreciate the question. The dumbest argument I hear from flat earthers, what is the dumbest argument that I hear from flat earthers? Yeah, it's that the sun sets because the sun gets too far away to see. And I'm like, look, we've all seen some sunsets. The sun isn't getting further away and dimmer, it's just getting lower in the sky. And yet they somehow think that it's getting further away. From Buchanan with the $5, thank you so much. By the way, guys, remember, if you want to get your question to have a guaranteed answer, or at least get me to read your question even if I don't know the answer, send a super chat. It's a good way to support me, and it's a good way to get your question answered. Is there an exotic hypothesis or speculative idea in physics that you're fascinated by? Not that you think is true, but just interests you? Yeah, actually lots of these ideas. So I'm really interested in possible explanations for the early universe. So like basically if it has to do with the cause of the Big Bang, I'm very interested. If it has to do with the nature of dark energy, I'm very interested. If it has to do with entropic, or if it has to do with like you know, yeah, those are the kinds of things that I'm very interested in. And so like I read tons of papers that are like a new model for XYZ, which purports that, you know, the inflaton particle is responsible for the rapid expansion. Like those are the kinds of things that are interesting to me. It's the biggest. Oh, I've answered that question a few times now. If the universe is created intentionally, would that not solve problem of probability? Depends on how it's created intentionally. What's the most surprising thing that's actually true about the universe? The surprising thing that's actually true about the universe. Maybe that, and this is just like, this is just surprising from like an intuitive perspective, that when we look out at say the stars, we're looking at things that happened long before we were born. Which is weird, because the things that we typically look at are so close that it may as well be happening. The things that we're seeing may as well be happening right now. How much do you read about other fields? Not really at all. Thoughts on Mons? Junk science needs work. I don't think it's true, but I wouldn't call it junk science. It's serious science. I just don't think that they're on the right path. Is it true that photons don't have well-defined reference frames themselves? If so, why? Yeah. So in order to have a well-defined reference frame, there must be a transformation, it's called the Lorentz transformation, from any other reference frame to the reference frame in question. However, no such thing exists mathematically. You'd have to divide by 0 in order to write down such a thing, and you can't divide by 0, so the reference frame doesn't exist. From JJ Master with the 2 pounds, dark energy and inflation equals the same thing. Not necessarily, but they could be related, because they both seem to have similar kinds of behaviors. What's the difference between a paper and a PhD thesis? A paper is A, usually shorter. B, it is usually more focused. It has less of a background, less explanation. And a PhD thesis is often a researcher's first paper in some sense. Let's jump down to the bottom. Can you change the order of events in GR as long as they occur? Only if they are spatially separated, meaning that they are not within each other's past or future light cone. I was watching a lecture on QFT, and he said that C and H bar are taken to be 1. Why is that? Well, so these are quantities with units, so you can just choose a set of units so that C and H bar are 1, right? You can just choose those units. Like, you know, for example, in standard SI units, the speed of light is 300 millimeters per second. But if you instead use units of light seconds, then the speed of light is 1 light second per second, right? You can also just choose them to be unitless, in which case meters and seconds become interchangeable, or distances and times become interchangeable. First year PhD student, condensed matter theory here. How do you know when the calculations for a model that you work on are enough for a paper, or if it must be a segmentation into multiple papers? So it's often... So nobody's going to get mad at you for your paper being too long unless it's like more than 100 pages. I've seen papers that are like my first paper was 71 pages. So nobody's going to get mad at you. It just means it'll take longer to review, and it won't get published in one of these like letters journals, but that's not really an issue. The issue that you might often run into is you're just like, the issue that I sometimes run into is, when do you know that you've done enough? Not like, have I done too much and that this needs to be split into multiple papers? And if you need advice on this specifically for your field, for the project that you're working on, ask your professor, that'll help. From HollowZ with the $20, thank you so much, HollowZ. Imagine discussing a topic with someone and you start to realize they're not intelligent enough to comprehend the subject matter. How do you handle this politely? It is a coworker, by the way. How do you handle it politely? Politely. I mean, you could just slowly change the topic. Like, if they're not intelligent enough to comprehend the subject matter, then it's not worth talking to them about it. Right? I wouldn't like abruptly do anything. I also probably wouldn't start like trying to teach them unless they asked you to, because that can seem condescending. You speak to Tyler lately? He's gone radio silent on my side of things. I haven't, but he and I are like, we usually just send memes to each other, but I don't know the last time I got a meme from him. How are you feeling after your surgery a few months back? I'm doing okay. I might have celiac disease though, which kind of sucks. Do you think information is more fundamental than matter in space-time? Not really, no. Do you think AI will lead to any major breakthroughs in physics? I suspect not major ones, at least not anytime soon. Do you believe in wave-particle duality? Sort of, but only insofar as they're neither waves nor particles, or they're not particles, they're definitely waves, but they sometimes have particle-like properties, so you can call them wavicles if you want. How are Babs and Big E? They're okay. They're okay. Sorry, I have to jump down to the bottom. Oh, actually, let me hydrate. I gotta stay hydrated. Did you give physics Olympiads? No. No, I did not. Oh, did I? Oh, no, okay, good. If every particle has a quantum wave function, what causes one outcome to become reality when it's measured? This is one of the biggest problems, and it's called the measurement problem. The answer will depend on what your preferred interpretation of quantum mechanics is. Can you explain local and non-localness? So all local versus non-local means is, local means that things can influence things in their immediate surroundings. at a finite speed. So if you impose locality, what that really means is that there's no way for thing A to influence thing B faster than the speed of light. I never had physics and want to study physics at a university to become an engineer. Will you make it? Yeah, absolutely. That's no issue. Do you dream of a Nobel, or is it something you don't think about? I used to think about it a lot. I don't think about it that much anymore. Do you have AC? Yes, but I also don't live in Europe. So can you comment on Sully thinking he educated you in debate about k equals 4/3? That it's embarrassing that he thinks that. That's my comment. Could you see yourself being interested in teaching high school or middle school students? Not really. Does an object have to be set in motion in order to be in motion? Well, in some sense, yeah. Unless it was already in motion, of course. Do we know why there's spin? Yeah, it's basically because angular momentum is conserved, and we treat particles as this is a technical answer, but we treat particles as if they are fundamental representations of something called the Lorentz group, or the Poincare group, depending on what you prefer. Do you think life will get increasingly difficult from climate change? Depends on where you live. It's going to impact places very disparately depending on their geography. Would you be happy if you got a Fields Medal instead of a Nobel Prize? Yeah, but that seems far less likely considering that I'm already 33 and you can only get them if you're 40 or younger. The laws of physics are the same everywhere. Why do the constants of nature have the exact values they do? Who knows? What scientific fields are in most need of people or research? I don't know. I don't know a lot about other scientific fields. Is GR just conservation of momentum in disguise? No, not at all. Hold on. Let me drink some more water. Is it the applied or theoretical physics they have expertise in? So I am a theorist in some sense. I'm a mathematical physicist. So I do more of the theory side, but I know a bit about experimental stuff. What's your favorite hypothesis about what dark matter physically is? I would really like for it to be tiny black holes. These are called primordial black holes, PBHs, and that would be a really, really nice answer. But as we get more and more data, we're ruling out more and more possibility space for that to be the answer. Why is there even stuff instead of nothing at all? Well, go ask the philosophers that. Do you think there is any possibility for separate dimensions or anything paranormal? Possibility? I mean, I guess, but I don't think it's true. I think possibility is cheap. I've heard that you can split energy into matter and antimatter, but how do you interact with pure energy like photons? So there's no such thing as pure energy. There are particles. Those particles can either be matter particles or non-matter particles. Photons would be an example of non-matter particles, but these are particles nonetheless. And they have energy, they have momentum, they have angular momentum. And you can, in the right conditions, convert these non-matter particles into matter particles. And when you do so, you'll end up with matter and antimatter, typically. Well, always, rather. Are gravitational waves detected in a LIGO discrete packets of integer number of gravitons? If gravitons exist, it kind of. What's your favorite method of solving PDEs? Plugging it into Maple. You have a girlfriend or boyfriend? I have a wife. Is Hawking radiation a thing? Does it have any observable effect? Hawking radiation is a thing. So long as general relativity is true, at least at reasonable scales, and quantum field theory is true, again, at least at reasonable scales, then Hawking radiation is a thing. Does it have any observable effect? No. Not at least for regular-sized black holes. Your thought about aliens smarter than us? They could exist, but I don't think that they visited. Is dark energy necessary for the universe's existence? Not necessarily. Just read an article that darkness moves faster than light. What is darkness? I have no idea what that paper is referring to. Opinion on Orch OR? I don't take it particularly seriously. What's outside the universe? There isn't one as far as I'm concerned. Does climate change have any effect on current physics? Not really. Is the homogeneity and isotropy of the universe a good argument for the infinite space? It's not a good argument. So if you assume that the universe is homogeneous and isotropic, it doesn't have to be infinite. However, that is the simplest explanation for it being homogeneous and isotropic. About what's surprising yet true, for me it's that we fall due to the curvature of time more than space, from what I've heard. It's not that time and space are separately curved, it's that the effect of curvature of space-time affects the time dimension more than it affects the space dimension by a factor of c squared, the speed of light squared. So spatial curvature is always going to be subdominant to curvature in the time direction, if that makes sense. Where does the universe stop? It's not clear that it does. Is there an approximate completion date for the large interstitial gravity mass? Good joke. Do I know Professor Dragon? No, I don't. Is there any similarities between how quantum mechanics and relativity see space-time? Any similarities? No, not really. I mean, they both see it as four-dimensional, I guess, but that's about it. What does it mean that we don't actually touch as in our atoms? I mean, it's not really true. Like, things touch into, like, fundamental particles are not tiny little billiard balls that can, like, either touch or not touch. Fundamental particles are fuzzy, like electrons are fuzzy. And so they're spread out, and they definitely do overlap with other electrons. So in that sense, they do touch. Actually, I should make that video. You never touch anything. All right, noted in my notes app, and I'll make the video eventually. Do you have a different theory outside Einstein of relativity? No, not really. Could suns not be the opposite of black holes, for lack of better words? Well, yeah, they're not the opposite of black holes. I don't know what the opposite of black hole would... I don't know what properties we're talking about that it should have opposite. There isn't a universe? I'm confused. No, there isn't an edge. There isn't an outside the universe. What sci-fi universe inspired you to become a physicist? It wasn't a sci-fi universe that inspired me to become a physicist. Well, is the universe isotropic? It seems like it is. What's happening with CERN? They're shutting down the Large Hadron Collider to make time for upgrades. Do you enjoy pineapple on pizza? I don't. Have you researched the therapy of gravionics? That doesn't sound like a real thing. Blitz, would you rather it be 110 Fahrenheit all the time or -10? Oh, I don't know. I don't know if I've ever even been in -10 Fahrenheit. -10, maybe 110, because at least you can go inside. Well, I guess you can be inside when it's -10 as well. Yeah, I'd rather it be 110 all the time. Epic rap battles, Bill Nye vs. Newton, who won? I don't remember. I saw that. If it exists, I'm sure I saw it a long time ago. Universe can't be finite if it is defined as everything that exists. No, it still can be finite. It just can't really have an edge. Where will we go after we die? Well, I don't think that we go anywhere. What do you think dark matter as what do you think of dark matter as a mathematical physicist? Well, I don't have like a set in stone opinion, but it'd be nice if they were microscopic black holes. That'd be fun. Does free will exist? Well, I don't think so. But it depends on what you mean by free will. How contested is Noether's theorem? That Noether's theorem is not contested whatsoever. It is a mathematically true theorem. Why don't they use variable mass in relativistic collisions but invariant instead? And how does adding field energy to particles when accelerating them affect quarks' kinetic energy? Field energy to particles? I don't know what you mean by field energy to particles. But variable mass is just not really a thing. Like, it's just not really like a useful concept. Invariant mass is pretty useful because it's the same regardless of reference frame. If Pluto's a failed planet, brown dwarfs are failed stars, then all of us are failed black holes. I guess, yeah. Are higher dimensional beings possible? Possible, perhaps. Likely, I don't think so. Shroud of Turin, keep coping. The irony of that statement is palpable. Do you like 60 Symbols YouTube channel? Features a lot of Oxford physicists. I do. I used to watch them a lot, but I just don't watch a lot of YouTube anymore, so... Why do we use Fahrenheit? Fahrenheit was just a scale that was invented by some guy, like, I don't know, 200 years ago or something like that, maybe 300 years ago. And it's really convenient for human experience, right? So that's why we use it. If pressure causes almost anything to turn solid, do gas giants have a solid surface under their atmosphere? That is something that I've been looking into. Apparently it's not clear. So what is likely the case is that Jupiter and Saturn probably don't have a sharp dividing line where it goes from like gaseous or liquid to solid. So it's not like there's a ground, like a well-defined surface ground on Jupiter or Saturn. It's more of like a gradual transition from like gas to like super dense like metallic hydrogen or helium or something like that in the core. They probably don't have solid ground at all. Like they probably don't have a solid core at all. It's not clear if Uranus or Neptune have solid cores. The data is kind of consistent with both, so having a solid core or not having a solid core. It's also not clear that even if they have a solid core, whether or not it's kind of a gradual transition to solid or if it's a kind of an abrupt transition like we have on Earth where we have atmosphere and then ground. So this is actually like really this is really like there's a lot of stuff that's not known about like the inside of these large planets. Do you have any opinions on the Steinhardt-Tarok model of the universe? Is that the what's it called, the ekpyrotic universe? Yeah, that is the ekpyrotic universe. I think it's cute. I think that it kind of relies on like extra spatial dimensions, which I'm not particularly convinced by, but I think it's cute, and I think that they're doing some. I think that, you know, Steinhardt has made significant progress, has made significant, you know, significant developments on that front since then, and I think that he's doing very interesting things. For the purposes of CERN, whether mass is variable or invariant ontologically is pure convention. Okay, sure. Does light decay point? That's not. I don't know what that question means. Light, as far as we can tell, light does not decay. Do jobs care about university's prestige? It depends on what kind of job. Some jobs will, definitely. What got you interested in physics, debating and going to university for physics? I saw a rendering of like a black hole when I was a really young kid, and I've been hooked ever since. What are your thoughts on NASA lost the technology to get back to the moon? They didn't. They didn't lose the technology. Oh, read my message. I'm so sorry. I'm so sorry. Okay. Wait a minute. In live mods? I'm in live mods. I don't see anything. Oh, there's another mod to add. Okay, cool. Let me add another. Let me take a quick minute, y'all. Moderators, add Joe. Wait, there's two of them. Oh. One has an E. Okay, cool. Done. Sorry, I wasn't paying attention. I had a different thing up. So Feynman, Einstein, and Schrodinger walk into a bar. Feynman says, it appears we're inside a joke. Okay, good bit. What is M theory and how is it different from string theory? My understanding, and I'm not a string theorist, so, you know, we do have a resident string theorist who hangs around here. My understanding is that M theory is merely an attempted unification of the 5 different kinds of string theory. But M theory is we know a lot less about what M theory would be because I guess it's so-called non-perturbative. Why do orbitals exist and what is the physics behind them in atoms generally? So orbitals are merely the shapes that electron clouds can take when they are at different energy levels in an atom. Now, why do they exist? They exist because electrons are clouds. Electrons are like they're distributed, their mass is sort of distributed in some sense. And the shapes that they take, the reason they take those shapes is because of the way that an electron, which has a charge, interacts with the charge of the nucleus, which also has a charge. Positive and negative attract each other, but the electron can also have angular momentum, and then the angular momentum will affect the shape of the orbital of the cloud that the electron has. What do you think is past the space-time boundary? I don't think that there is one. At least I lean that way. Gravity does not have the same properties that electromagnetism does. True. Why is the US so antimetric when it is easier to calculate with a base 10 counting system? It's just convention at this point. Did you think black holes were flat when you were a kid? I remember my mind being blown when I found out they were three-dimensional. I don't remember. Honestly, I don't remember. Wish I did. Where do I start learning physics and what math requirements do I need? Classical mechanics. Classical mechanics is traditionally where you start, but you will need calculus. Could spacetime be a physical substrate with a maximum compressive and tensile limit? It would be kind of weird if it was. But like, look, lots of like, a lot of this speculative stuff, like, you got to write down the model that makes it work, and if it makes it work, then I'll be like, oh, interesting, maybe that's true. Otherwise, it's kind of just like a shower thought, and it's really hard for me to evaluate it. You strawmanned me. I don't even know who you are. Can a three-dimensional being interact with a fourth-dimensional being? Sure, as long as the fourth-dimensional being is intersecting the three-dimensional manifold on which the three-dimensional being exists. Thought the question of whether gas giants have solid surfaces was answered already. I didn't know. We still don't know. Yeah, no, this is like a very hard question to answer, because like, how would you know, right? You have to know like the entire structure of the planet, and how would you know if you haven't been there? It's hard to do. It's hard to do, especially because like a lot of this stuff is like high density matter is complicated. From Chase Martin with the $5, such an interesting topic. Would love to discuss string M theory one day. Yeah, that'd be good. So when I was taking, I took 2 courses on string theory when I was a grad student, and none of those courses talked about M theory at all. So I don't really know a lot about it. I just know that Ed Witten is responsible, and that, you know, I know a few other things, but not much. Can pre-geometric quantum gravity instantiate autonomous cognition before spacetime emerges? I don't even know what you mean by autonomous cognition. What is a geometrical fourth dimension? It's just a space that requires an extra number to specify location. What do you think about quadratic gravity? I haven't looked into it too much. I like versions of quadratic gravity a lot, especially the conformally invariant version of quadratic gravity. But it has some issues, namely that like it's hard to, I mean, it has a lot more free parameters, right? And I guess that it's also becomes fourth order, which becomes a lot less stable mathematically. And so, you know, there are some issues. But I like it a lot. I think that it's I don't think that it's necessarily false. My goal is to major in physics next year, but should I aim for a PhD? I'm going to the University of Illinois, UIUC. So UIUC is really, really good. Should you aim for a PhD? It just depends on what you want to do. You have a chem degree? No, I have a physics degree. Actually, I have 3 physics degrees. I'm currently studying physics at the University of Vienna. Is it internationally known as a good university? Yes. Although there is something to be said that Americans prefer American universities as far as like PhD students for some reason. Well, not for some reason, it's bias, but could you watch the heat death of a universe if you were behind the black hole event horizon? If there are still black holes, then the heat death hasn't happened. Where's the fun come in studying QFT? Well, I don't do QFT for that reason, that I don't think that there is fun that comes in. Is it true that gravity leaks into other dimensions? If there are other dimensions, maybe. Do you think AI and quantum computing will make breakthroughs in physics? Quantum computing, definitely, because advancing quantum computing is physics. It is a breakthrough in physics. AI is hard to say. Why didn't you become a quantitative trader? Because I would rather kill myself. Is a physics degree highly employable, and is the pay good? It used to be. I don't know if it is anymore. I don't think anything is highly employable these days. Are we living inside a black hole? I suspect not. What area of mathematical physics are you currently working on? So I do conformal geometry, and I do early universe cosmology with like early universe classical cosmology and some black hole physics. Mathematical physics doesn't really have an area, if that makes sense. Mathematical physics is kind of the name of the kind of physics that certain kinds, or the kind of live restricted. God damn it. It's because I said the thing about quantitative traders. God damn it, the live will be restricted for 10 minutes. The one time that TikTok actually cares about what I say. All right, we'll give it 10 minutes. It'll be unrestricted in 10. What's your biggest issue with people who claim we didn't land on the moon? Well, they're just like they're conspiracy theorists, so they're not willing to like evaluate the evidence objectively, right? Like they think any evidence in favor of the moon is part of the conspiracy, and the like random pieces of data that they think is evidence against the moon landing, they think that that is evidence. So like, what things should I learn in high school to prepare to go into particle physics? Calculus. Do fabric of space-time bend to every mass, including us, or massive objects only? Everything. Do you think the Library of Alexandria would have evolved science better if it were still standing? Not really, no. Oh, I need to drink some water. Why did you straw me in your YouTube video? Oh, did I make a YouTube video about it and you're mad about it? Okay, let's go see what the YouTube video is that I strawmanned him in. Because I'm curious now. I really want to know. All right, let's see. Let's filter by description, dark MAGA. Which YouTube video was it? I don't even remember you. I showed you a model. Who are you? I don't know who you are. I guess I could plug in my yeah, let's just 1 sec. Let me do a thing. Plug in my external hard drive that will have all of the videos saved on it. All right, I'm kind of curious now. Flat Earth conceptual model. Okay, I'm gonna go to the external hard drive. And then when did I... Okay, so your name is Dark MAGA? Unless your name changed. Yeah, I don't think I made a video about you. It's on a live stream 6/15/26. Okay, so it was recorded on 6/15. Let's see. Wait, are you the guy that crashed out over slavery? Or are you... No? Yeah, are you the guy that crashed over slavery? Because that's the only live stream that I posted from that day. Huh, yeah. They all think they're unique, but they all have the same arguments and talk like sheep's true. If he's crashing out here, I bet there's a video. I bet he crashed out in a video. I guess not. I guess he didn't. Because I didn't make a video out of it, and I always make videos when there's crash outs involved. I don't see how you could possibly strawman someone called Dark MAGA. He had it coming. True, right? True. Why does gravity have a speed limit if it doesn't have mass? Well, light has a speed limit, and light doesn't have mass. Let's read some more questions. By the way, if you want to support me, there's a few ways that you can do that. Probably the most consistent way to support me, and honestly most affordable way to support me, is just become a member on YouTube or become a subscriber on Twitch or a superfan on TikTok or a Patreon on Patreon. It'll, like, the lowest tier is going to be $5 for all of them, and you get some perks. So you get access to my debate notes, you get access to ask questions on Ask a Physicist Day after 10:30 in the morning. You get access to a private Discord channel in the Discord server. You get access to some emojis. So, you know, there's reasons to support me beyond just supporting a creator that you like, but if you just want to support a creator that you like, that's one way to do it. It's a good way to do it. From Chase Martin Physics with the $10, the non-perturbative is the interesting part. Take the coupling weak to strong, and an 11D radius goes from 0 to some value. The 1D string vibrates freely in 11, so it is a 2D membrane wrapped on an S1. Oh, interesting. Yeah, I mean, we probably have stuff to talk about. Like, you know, you should just make videos on this stuff directed at people with PhDs in physics, but not necessarily string theory. That'd be good. I'd love to see that. Do you think it's possible to get over the mass problem in radiation buildup in the warp drive papers? The issue is that you need matter with negative mass, and I don't know if that's possible. What do they mean by time ending in a singularity is the end of the sequence of events? Yes. Depending on the kind of singularity. If it's a space-like singularity, then it is the ending of the sequence of events. How do you think AI will impact day-to-day physics research? I don't know. Well, that is to be seen, right? I meant light. Well, so look, things without mass travel at the speed limit. Things with mass travel slower than the speed limit. Are you as annoyed as I am that the Artemis didn't have any live cameras for the whole flight? Well, you mean it didn't have any cameras that were live for the entire flight? I mean, I'm not annoyed by that. It seems reasonable. Does string theory support light as a wave or a particle? It supports light as an excitation of a string. Are you on Kick? I'm not. No. The debate notes are really nice. Yeah, and I add stuff to them fairly regularly when I find new stuff to do. Why is the universe so homogeneous on large scales, and why are electron wave functions localized around atomic nuclei? So to answer the first question, in some sense it's an open question. If you think that inflation is true, that would explain why the universe is homogeneous on such a large scale. Electron wave functions are localized around atomic nuclei because there is a strong electrostatic attraction between the electron and the nucleus. And so that's going to localize it because there's something that is pulling the electron towards it, namely the nucleus. Why do physicists believe gravity isn't a particle the way they do photons or other non-matter particles? It's just not true that physicists believe gravity isn't a particle. It's just that we just don't know. Do you have any thoughts on the possibility of electroweak symmetry being related to baryogenesis? There are, so it could be, but it doesn't seem to be enough. QFT versus classical theories of negative energy. Oh, where'd the question go? Wiki says they slightly disagree since one requires the energy conditions. GR still works with negative mass, right? GR does work with negative mass, yeah. Any thoughts on dark matter possibly being WIMPs? It's an idea that people take seriously. I'd like them to be primordial black holes, but that's just me. If we created a model with no contradictions, what will the excuse be then? NASA CGI? If you create a model that like adequately explains all of the data, and is able to make predictions about the world around us, that'd be really good. But flat earthers would never do such a thing. Sorry, if they make predictions about the world around us that are distinct from the predictions made by any sort of globe earth model, and the flat earth models come true, that'd be excellent, but that will never happen. Can you explain the final stages of a star into a supernova mechanistically? I have a video on this where I go into it in detail, but essentially what happens is that you have the star starts collapsing downwards because fusion has stopped higher up. It starts collapsing downwards, and so you have a shockwave coming down. Fusion is still happening. Atoms are being fused into iron and nickel. Fusion is still happening in the core, but at that point, the core is going to be mostly iron and nickel. At that point, the collapsing shockwave from the outer layers of the star, they hit the core, which is iron at this point, iron and nickel mostly, and it'll send a shockwave through it. That shockwave is going to cause the and some of the shockwave is going to be transmitted. Some of it will be reflected. Anyway, that shockwave will cause additional compression of the iron, which will cause it to which will cause the iron, the electrons in the iron to be captured into the protons and form neutrons, and they'll form a new stable state, the neutron star. On the other hand, during this process, during this recombination of electrons and protons into neutrons, you have the emission of neutrinos, and so you have a ton of neutrinos that are emitted. And those neutrinos, they can kind of catch that infalling shockwave, which is extended, and they can kind of push it back out so it goes outwards. It's a little bit like that. I probably got some of the details incorrect, but if you want to see the details more correct, go check out my TikTok video on it. I do go into the details there. I think the video is also posted on my YouTube channel, on the vertical YouTube channel. So where I kind of go over the steps explicitly. But yeah, essentially there is an event where the iron collapses under its own weight. It forms, the electrons are absorbed into protons to make neutrons. During that process, they release tons of neutrinos. Those neutrinos then accelerate out the explosion and kind of kickstart the thing, and that's what causes the supernova. No, but Wade, does light have a speed limit if it doesn't have mass? Yes, light has a speed limit because it doesn't have mass. Well, everything has a speed limit. Light just matches that speed limit because it doesn't have mass. Never understood how higher energy photons can still go at the speed of light. Well, they're higher energy, but their energy isn't just carried by their speed, it's also carried by their frequency. Any view on the hypothesized idea of helium-3 mining on the moon? Could it be an energy market like if we found it? Maybe. It's only an energy market, though, if we can start doing nuclear fusion in an effective way. As far as I'm aware, that's the only reason why helium-3 would be nice. Would iron become metallic like metallic hydrogen in Saturn? Iron is already metallic. Would iron become metallic? When iron's a solid, it's always metallic, as far as I know. I read that we fairly recently managed to transport antimatter. Can you please explain how this was achieved? So I don't know the details, but what you remember reading is that for the first time we drove it in a car. So we've been storing antimatter for a while, and we can even move antimatter around a facility, but trapping antimatter, putting it in a car, which is like, can be particularly, bumpy and such, that's the achievement. Now, I don't know the details. I imagine they use some sort of electromagnetic confinement method to store this, to store and transport the antimatter. And then they just loaded it in the back of a truck and they drove it around. They drove it around the campus of CERN. Try debunking the Elliott argument? I have, yeah. The first premise, which offers I think maybe it's the second premise. One of the premises offers a dichotomy and it's a false dichotomy. So, argument debunked. Problem solved. Do you believe quantum entanglement and synchronicity work hand in hand? No, I don't think so. How can light interact with mass if it doesn't have mass? Like, what is something that isn't something? Having mass isn't the same as having something, right? It's not matter. It's just a different kind of particle, but it's still a kind of particle. It can still do stuff. From Carl Bush with the 14 Canuck bucks. Thank you so much. Is it possible the missing antimatter collapsed into black holes before annihilation? I mean, I guess it's possible, but it seems very, very unlikely because that would mean that for some reason the black holes preferentially swallowed the antimatter rather than the matter, and that just seems extremely unlikely. Why do physicists not use Finsler geometry? I think some of them do. I don't, but some of them do, definitely. Is anyone going for the Nobel Prize for figuring out dark matter? Whoever figures out dark matter will probably win the Nobel Prize, yeah. Is it true the observable universe is 90% empty? It's more than that. Like, on average, most of the universe is empty because the universe is really big and mass is just not very well distributed. Where did you debunk it? Oh, I didn't debunk it in a place. Like, I just debunked it just now. But I did debunk it in Elliott's live stream once, and then he banned me. So that shows you how sure he is of his beliefs. I debunked it in the chat, and then he banned me. He would never invite me up for a conversation. How does Noether's theorem change when symmetries are local instead of global in QFT? Then you get, well, then you don't get global symmetries, right? Then you get, like, gauge invariance and stuff like that. No, the Elliott argument's actually never been on my live stream. I've never spoken with him live because I've tried to go into his live stream and he banned me in his chat before I could, and he didn't let me up, and he's never come on my live stream either. But mass is how much of something there is. No, mass is not how much of something there is. Mass is just a measure. Essentially, it's a measure of its energy that it has when it's at rest. What do you think is the matter that we know is present in the universe but we can't measure? Whatever dark matter is. I mean, we can measure it just indirectly. Wow, you mean some dude pushing a shitty argument doesn't like opposition? Wild, yeah, I know, right? He's too afraid to actually, like he's been challenging people, he's been challenging me and others to go on, like, a neutral platform that's, like, moderated. I offered to go into his live stream and he wouldn't let me up. Could dark matter be large neutrino-like relic particles with mass but no EM interaction? Plausibly, there is this idea that dark matter is like a sterile massive neutrino. But it couldn't be neutrinos that we think of. It couldn't be light, like low mass neutrinos, right? Yeah, he's been in my chat. He hasn't come up before. He's too afraid. Do you genuinely believe the heliocentric model gifts? I don't form my belief based on gifts, unlike flat earthers. Do you have a job, or is this your job? In some sense, this is part of my job anyway. I do science communication. So to pay the bills, I do science communication. I do debates. I do Q&As. Primarily. That primarily pays the bills. There are some other things that I have like going on that also help pay the bills, but primarily this. So I spend about 40 to 50% of my time doing this, and then 40 to 50% of my time doing science, doing mathematics, doing physics. Do you think once the full data eventually are available from Euclid Space Telescope, DESI, Vera-C, that we will get dark energy evolution parameter not equal to 0 with certainty 5 sigma? I don't know. I hope so. That'd be really interesting. What field of physics are you in? When I do physics, it's physics that involves gravitation. Do you think that there is no cosmological constant in Einstein's equations? I lean that way, yeah. Bit of a layman question, but what's the difference between antimatter and dark matter? Yeah, so, I mean, look, this is a common question, so don't feel bad about it. So antimatter is a lot like regular matter. It's almost identical to regular matter, except there's one difference in that all of its charges, all of its features, except its mass, are flipped. So if an electron has negative charge, then an antimatter electron, called a positron, has positive charge. So everything is flipped. Dark matter, on the other hand, is not at all like regular matter. As far as we can tell, it's just stuff with mass. It interacts gravitationally, but it doesn't really interact with anything else. So it's not antimatter, it's not matter that we're familiar with. It's just a different kind of matter, and it's just really hard to see because it doesn't interact with anything, so it doesn't interact with light in particular, hence the name dark. But it does have mass, and so it would have gravity. From Mr. Kiki and from Mr. Kiki, wait, are Dark Maga and Sully the same person or two separate idiots? Oh, they could very well be the same person, but I wouldn't be surprised if they are two separate idiots. Do you genuinely believe we're hurtling towards a supermassive black hole? No. We may need more extensive about page listing commands, links to the profile page, etc. That's a okay. Make the suggestion in the Discord server, and then we can work it out. If someone said, I hate disabled people and neuroatypicals, that would be ableist. That would be ableist, yeah. Who is this, Elliot? A guy with a CTE, or with CTEs. He was a former football player who retired probably because he got hit on the head too many times, and now he writes AI books. Writes. If space is expanding, can it also contract again? It's possible, yeah. How does super chats work, and is there a character limit like with TikTok? There is a character limit. The more that you send, the bigger your character limit. People can send, like if you send more than $10 or something, you basically have an unrestricted character limit. It's not literally unrestricted, but it's quite large. And so, yeah, it's just like, you know, you send $5 or whatever, and you can ask a question, and I will see it. I will read it. What was your first publication? Was it in grad school? Yes. So I at least submitted it for publication the winter before I graduated, or maybe it was the fall before I graduated. It didn't get accepted for like, you know, we submitted it to a mathematics journal, so it took a while for it to get accepted, but I think it got accepted like 2 years later or something like that. It finally got published, rather. Do private sector scientists do different work than public sector? Yeah, definitely. 100% they do. Public sector scientists, private sector scientists, when they're doing private sector science, their goal is to increase shareholder value, right? Differential geometry is fun. I agree, it is fun. What happens when Milky Way merge with Andromeda? Well, if it happens, because we're not sure that it's going to happen anymore, if it happens, then essentially nothing bad will happen to our planet or, you know, our local neighborhood, because during galaxy collisions, stars rarely run into each other. But what will happen is that our galaxy won't be a nice disk shape with spirals anymore. like whatever the resulting galaxy will probably just be a big clump of stars. Gravity is tied to light. Could you go in a box and escape gravity? Gravity isn't tied to light. Can you give a reason to reject the A theory of time for a non-physicist? Yeah, because the physics seems to prefer the B theory of time. Now I could explain why that's the case, but you wanted it for a non-physicist, so. Have you been approached by government to work on secret military projects? If I had, do you think I would tell you? Brazilian physics student hoping to advance science or die trying. One tip for a beginner. Read more than you think that you need to. Why are planes able to fly inverted? Because as long as they're angled upward, or depending on the shape of their wings, of course, as long as they're angled upward, they can generate lift. As long as the wings are angled upward, I should say. Hurling towards a supermassive black hole is the heliocentric model. Oh, no, it's not. I'm a mathematician. I have a way to obtain an interaction equation of standard form. Of standard form, a Riemannian point of view. I find it very confusing. It seems as the mass seems to be an intrinsic. I don't know what you mean by obtain interaction equation of standard form, a Riemannian point of view. Oh, wait. To obtain interaction equation of standard model from a Riemannian point of view, maybe? How can light have no mass if it has energy? Well, because not all things that have energy have mass. Please tell Mrs. Blitz we love seeing her. Okay, I will. She can't hear me. Oh, are we the closest to the smallest thing in the universe or the largest thing in the universe? We're closest to the largest thing in the universe, if I remember correctly. Actually, wait a minute, hold on. So 10 to the minus 35. Yeah, we're close. No, we're closest to the largest thing. Can you give an intermediate answer for the B theory? Yeah, so roughly the idea is that when you travel close to the speed of light, not only does time dilation happen for you, so like your clock seems to slow down relative to others and vice versa, and not only does length contraction happen, that things seem shorter from your perspective than they do from other people's perspective, but also what you call now tilts relative to what other people call now. So if somebody thinks that two events are simultaneous from their perspective, it might be the case that two events are not simultaneous from your perspective if you're moving at close to the speed of light. One thing might be before or after the other. So your sense of now, if your sense of now is equally real as their sense of now, then in some sense, all senses of now should be real, but your sense of now could be, part of your sense of now could be my future, depending on, you know, what direction you're traveling in and how fast you're going. And so that would mean that, like, in some sense, the future should be just as real, because it's part of your now, as the present, and similarly the past. From JRM with the $5, I don't really have a question, just wanted to let you know a lot of us appreciate your work. Have an awesome rest of your week, Doc. Cheers. Well, I appreciate that. Thank you so much, bud. Is it true that the universe is not inherently fundamental? Well, I suspect that that's false. What defines mass? Mass is the energy content of a system when it's at rest. Or put another way, it's the energy content of a system from its own inertial reference frame. Is there a limit to how big a rocky planet can get before it breaks up or heats up? I was looking into this yesterday, actually. Apparently, so there was some work in the early 2000s, I want to say, of someone trying to say that, oh, well, in principle, you could have rocky planets at up to a few thousand times the mass of the Earth, but it's not clear. Like, I think that we have some candidate rocky planets that are like a few hundred times the mass of the Earth, but that's like the biggest they get at this point. And those are not confirmed rocky. All right, so it is 10:30, which means that I'm going to turn on member only chat. Anybody can watch, but it's, you know, the only people who can send messages will be members only, which means that members, you know, on TikTok, YouTube, Twitch, etc., members will basically get guaranteed answers or guaranteed questions answered. I'm also going to be bringing up guests, though. So even if you're not a member, you can still come up and ask questions as well. So let me just take care of that really quick. And I'm going to have to restart the TikTok live. So I'm going to say goodbye to you, and I'll say hello to you again in 2 seconds if you're watching on TikTok. Go live. There we go. All right, we are now officially in members only mode. Now, what that means, like I said, is that if you're a member, you can basically guarantee that your question will get answered. If you're not a member, you can still join up and ask in voice. But this hopefully will encourage people to ask questions and to become members to help support me. You get access to these twice a week, where I will be answering questions from specifically members and also from people who want to come up and ask some questions in more detail. This stream should last about an hour and a half. So there'll be another hour and a half of this. Most of the time, my live streams for members only will be an hour and a half after the public or after the available for everybody live stream is over. But you can think of it as just more of a transition. All right. Sorry, I just want to double check something. Are there any online or computer physics apps that visual and really cool? Lots of computer physics apps are really cool. I can't think of anything in particular though. As a physicist, are chads real? Do you believe in hypergamy? I don't believe in that red pill nonsense. Migraine, thank you for becoming a subscriber at tier 1 and now having subscribed for 3 months. I really appreciate that. Rate Star Trek series from best to worst. Deep Space Nine is the best, then Strange New Worlds, then TNG, then Voyager. Lower Decks should probably be above Strange New Worlds. Discovery is somewhere down there. The original series is somewhere down there. Enterprise is somewhere down there. I don't know. There's a lot of Star Treks now. So much better than yard work. Well, I'm glad you appreciate it. I'm glad that you think that it's better than yard work. All right, let's bring up Cecil Ferkelmeyer, who has a question.
Hey.
Cecil Ferkelmeyer, how's it going?
Great. Thanks for taking my call. Appreciate you. Look,
Yeah, what question you got for me?
Well, I'm far from a scientist or a physicist, but I do have a simple question for you.
Sure.
How important is skepticism in science?
If you mean like genuine skepticism, I think it's really important. If you mean like kind of pseudo skepticism where you just like say nuh-uh, 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 and just kind of like keep pushing the buck back, then I don't think that's particularly important. But like genuine skepticism where you like you withhold belief until presented the evidence and then you evaluate the evidence critically, I think that's super important.
Okay. Well, the reason I ask is because I'm sure you're familiar with Mr. John Clauser. He's a physicist. You
mean the guy from the 1700s who was a chemist?
No,
Oh,
you don't know about John
I'm sorry.
Clauser?
I'm sorry. I was thinking of there was a guy from the 1700s who did the energy conservation thing. Yeah, John Clauser. He was one of the Nobel Prize winners in 2022. Is that true?
That's right.
Yeah. So he was one of the guys responsible for the essentially the Bell experiments. Yeah. What about him?
Something to do with locality. And anyway, he's a real smart guy, but he's a bit of a skeptic when it comes to man-made global warming. And
okay.
So
he's also not a climate scientist, so I'm not sure that like his skepticism is not particularly important.
Okay, well, you just proved my point then. You guys have no room for skepticism whatsoever. Because
well, no, the climate scientists should so the skepticism that's relevant in science is the skepticism amongst scientists. If you're not trained in a field, then you're going to have a hard time being able to critically and rigorously evaluate the evidence that's present in that field.
Wow.
But look, this is not a debate live stream here. Today's not the time for debate. So
I just had no idea you were such a religious nut. Honestly.
Yep, apparently I'm religious for thinking that the experts should evaluate the evidence most effectively.
Yeah, because you haven't looked at it. You have no skepticism whatsoever. You're religious.
Okay. Well, you can come back another day if you want to crash out there, but today's not the day for crash outs. By the way, you can also join, if you're not on TikTok, you can join via the Discord channel. The link is behind me or above me or whatever. Sorry, I need to hydrate more. What comic book superpower is the most realistic? Tony Stark, because his superpower is being smart and rich. And it turns out that that's a really realistic superpower, right? Can you explain the components of the Einstein field equations and the interpretation of it? So the left-hand side of the Einstein field equation is the Einstein tensor. The Einstein tensor is built from the scalar curvature and the Ricci curvature. And the Ricci curvature tells you, the physical interpretation of the Ricci curvature is, imagine that you shoot out an arrow. Imagine that you're at a point and you shoot out an arrow in some direction from that point, and then emanating away from that arrow is a cone. So the Ricci curvature tells you how quickly the area, the surface area, or equivalently the volume of that cone, changes with distance. It tells you, for a given angle, it'll tell you, or for a given width of the cone, it'll tell you how quickly that surface area grows of the cap of the cone. The Ricci curvature, in some sense, tells you, in some sense, it is related to how much volume or how much surface area a sphere has as a function of its radius at that point. So that's the left-hand side of the Einstein field equations. The right-hand side is just the matter components. This tells you the energy. This tells you the momentum. This tells you the stress. It tells you the pressure. And those things control this particular combination of the Ricci tensor and the scalar curvature. Which is what the Einstein field equation says, that the matter content controls, or affects rather, the Ricci curvature. How much wood could a woodchuck chuck if a woodchuck could chuck wood? It's 42. I get all of my science facts from a guy Nathan Oakley. Yeah, it's a good idea. Coming in hot with, I have an honest question too. You just proved my point, you religious nut. I know, right? Like, don't know. Lots of the rich people is dumb as sack of nails. Well, that's true, but being rich and smart would be a superpower. It's also a realistic one, as in like this is something that could realistically happen. New member, what is the general schedule for these things? So these happen on Tuesdays and Wednesdays. They are essentially the first things to get canceled when I need to. So if, for example, I miss, if, for example, I have to cancel the last 2 days of debates for a week, so I usually do debates on Monday, Thursday, Friday, then I might cancel one of the Ask a Physicists so that I can do at least one debate, because most of the people who watch are very interested in the debates. But also, these are sometimes canceled for doctor's appointments. Specifically, the members only ones are canceled for doctor's appointments. Sometimes if I can't get a doctor's appointment in the afternoon, sometimes I'll schedule it for like 11. I do have a meeting every 3 weeks on Wednesdays. That's at 11, so I have to cut these short. But this is not that week, so these will happen. The Wednesday Ask a Physicist members only live streams. Those will happen 2 of every 3 weeks, roughly. Yay, we got my from C-Bar with the $2. Yay, we got my hubby a ticket to your event in New York City. Well, thank you so much. I'll be glad to see you there, guys. If you didn't know, I will be in the Bronx on October 10th for a live event with the other fellas from the Unapologetic Show. If you don't know what the Unapologetic Show, it is myself, allegedly Ian, and Justin from Deconstruction Zone. We run a show every Sunday where we talk to theists, and we make arguments and do philosophy and science and history. And so we're going to have a live in-person debate show on October 10th in New York, and you can get your tickets by going to www.paying-burn.com and then scrolling down and looking for the thing that has my face on it. Also, there will be hopefully a live in-person live stream. It won't have an audience, but it will be an in-person live stream with the 3 of us. We will be doing in some sense an in-person Unapologetic live show in the latter half of July, and we'll have more information on that in the near future. So if you disagree with any of us about whether or not God exists, or whether or not the Big Bang is real, or whether or not Jesus performed miracles, you can make sure to fly out to New York City, fly out to the Bronx, and you can debate us in person. We will be taking debates from the audience. And it's being hosted by Pangburn. Is the Higgs field in some sense the substrate of the universe? No, not really. The Higgs field kind of lives on top of spacetime. If you want to talk about a substrate, maybe spacetime is the substrate, but even then, it's not so clear. From Will Day, they ask, what does it mean for spacetime to have infinite curvature at a singularity? It means that if you try to calculate what the curvature is, the curvature can be described by various mathematical objects called, curvature tensors, like the Riemann tensor, the Ricci tensor, etc. If you try to compute one of these curvatures, In this case, a good example is the Kretschmann scalar, which is the square of the the square of the Riemann curvature. That curvature diverges to infinity as you get closer and closer to the singularity. Maybe we'll come to Dallas eventually, but Pangburn is in New York, so that's why we're going there. All right, let's bring up another guest. We have Lloydie. Lloydie. Lloydie, how's it going?
Hi, Dr. Blitz. How are you?
I'm doing all right. Lloydie, what questions you got for me?
Did you make it to your appointment okay yesterday, first of all?
Yeah, it was a Zoom, or it was a video appointment. It was just like like a follow-up with a doctor, and it was over Zoom, and so I was 10 minutes late, but it's fine.
Just seeing you like panic and run off.
Yeah, well,
what?
here's the thing. So and the funny thing about that is that, like, I realized, after talking with my wife about this, I realized I didn't make that appointment, because after that appointment, I'm supposed to schedule another, I'm supposed to have another follow-up in a month. I see this guy once a month. We didn't schedule another follow-up. So I think that his team just schedules things whenever they want. And I should have just called in advance and been like, hey, we need to reschedule.
Okay.
So that wasn't my fault. I didn't schedule it wrong. They just scheduled it without asking me when I'm available. So anyway, what questions you got for me?
It might be a bit of a stupid one, but I was just going to ask you about time dilation.
Sure.
I don't get how, say a person was traveling close to the speed of light, how they would age differently to somebody on Earth, but their biological clocks are the same. Do you know what I mean?
No, their biological clocks will slow down.
Right. Okay.
That's the important point. So every physical process slows down. In fact, like, literally time is slower for the person. Every aspect, like everything that flows through time, every aspect slows down.
Okay. Yeah.
And
so it isn't.
Go ahead.
Yeah. So it was just getting my head around the biological clock thing, like, but of course everything will. Yeah.
Like, all of the biological processes, all of those things involve, sending, or making, like, physical interactions between particles and stuff. All that's what biology is at the bottom.
Of course they do.
And all of those physical processes are going to be slowed.
Yeah, that makes so much sense. Sorry, it was a bit of a silly one, but
no, you're good. You're good. Anything else, or do you want to just call it there?
Just as well, like, if somebody's on the other side of the universe to us right now,
mm-hmm.
and they're on a call.
Yep.
Will they be on a call right now?
That depends on how fast you're moving.
Okay.
So there is a sense in which what now means depends on how fast you're moving and how you're moving and what direction you're moving in. So you can. The way to think about this, and it's really counterintuitive, is if you think of time as running up an imaginary axis, and you think of space as being like horizontal chunks of like along that axis.
Yeah.
Each moment of now being like one slice, then if you're moving, that slice can tilt.
Okay.
Relative to other people who aren't moving. Or if you're moving relative to someone, your slice will be tilted relative to theirs. And so what now even is further away will be different depending on how you're moving.
Yeah, this all came from me wondering about 40K and how they like react to things happening in the other side of the galaxy. You know what I mean?
I mean, it's obviously fiction, right?
Yeah. I was just wondering how it would play out in reality. Yeah.
Sure. Well, it wouldn't.
No. Anyway, thank you so much.
Of course. Have a good one, man.
You too, man. Bye.
All right, let me just make sure that I didn't miss any text-based questions. Are dimensional manifolds complete per dimension and stacked to make larger manifolds, or are multidimensional manifolds whole without parts? So you can some manifolds you can slice up into pieces. These would be called foliations, and you can sometimes find like foliations for, like not all manifolds have foliations, but sometimes you can find them. Well, okay, no, I guess anyway, but the point is that a manifold is a thing on its own, and then sometimes you can slice it up into pieces, into like lower dimensional sub-pieces, and then stack them, but not always. In a consistent theory of quantum gravity, is space-time itself emergent from more fundamental quantum information or entanglement, or is it truly fundamental at the Planck scale? We just don't know. We don't know what the consistent theory of quantum gravity is. In some sense, in string theory, which is a consistent theory of quantum gravity, it just might not apply to our universe. In that sense, space-time is fundamental. It's really like they're or at least it's arguably fundamental. There's a question about background independence in string theory. Can you explain the quantum Zeno paradox? I thought it was the continual interactions prevent time evolution of the wave function, but then why doesn't it always apply? Well, look, so the point is that certain kinds of interactions for certain Hamiltonians are discrete, right? And so the amount of, so like imagine that you have a few different buckets, and you start, and object A, or wave function A, starts out entirely in bucket A. Or the wave function starts out entirely in bucket A, and you have bucket A, B, and C. Now, over time, that wave function will spread out, and if bucket B is, not close enough to bucket A, then it'll take some amount of time for the wave function to be substantially within bucket B, so that when you would make a measurement, you could find it in bucket B. But if you make the measurements fast enough, there won't have been enough time for the wave function to spread out in any substantial amount of way, so the probability of finding it in bucket A is always going to be high, because it just resets every time you measure it. Now, it doesn't mean it's impossible to find it in bucket B. It's just less likely depending on the rate at which it expands and the energy gaps and things like that. Why doesn't it always apply? Because not every system is like that. From Will Day, also wanted to say you're my favorite science communicator now and a huge inspiration for my pursuit of my PhD in mathematical physics. Thanks, Blitz. Well, good luck. Yeah, I appreciate it. It's very, very kind of you. Haven't gotten in yet, but trying again next year. Good luck. I wish I could help. I wish I could help you in the application process. All right, let's bring up Dexter from Discord. Dexter, how's it going?
Hello, Dr. Blitz. I'd like to apologize in advance for my broken English.
Your English is fine. What questions you got for me?
So, I would like to ask for some beginner student advice, because I'm just starting my bachelor's program in physics. And in my country, we have something called a conversion bachelor's program, which is basically just one more year where you like study thoroughly things from high school. And well, this is very important for me because I would like to eventually get a PhD in mathematical physics, and I would like to do things right from the start. So I wanted to know, like, I was interested in your opinion about if there are any specific classes that I should focus like more intensively on compared to some other classes, if you know what I mean.
Sure. Yeah. The most important thing in any physics bachelor's degree will be making sure that you are never behind on the mathematics. Now, what that means is that you should come in being very, very comfortable with calculus. That will make your life significantly easier, because your first physics courses are going to be calculus based. And if you are not sufficiently comfortable with calculus, then that means that you will be struggling to follow the calculations rather than trying to understand the concepts and the ideas. And so that can lead to roadblocks for people very, very quickly. And it can lead to people like, changing majors or flunking out or whatever. So that's a good thing to avoid. And then you're going to have to keep up, stay ahead of the game with your mathematics understanding as you get to more and more advanced stuff. So if you when you finish your introductory physics courses, you're going to start doing stuff that's going to require like differential equations. Make sure that you know the relevant differential equations. Make sure you've taken a differential equations course, for example, or that your calculus sequence includes that, or something like that. So essentially, the best advice I could offer to anyone who wants to get into mathematical physics, especially people or for anyone doing a bachelor's in physics, especially people who want to do mathematical physics, you should never be struggling with the mathematics when you're doing your physics degree. The mathematics should always be stuff that you already know.
Yeah, understand. So basically, the standard curriculum that we have at my university is consists of the mathematical analysis, the calculus 1, basically.
Yeah.
Linear algebra, mechanics 1, and basically, I'm sure I forgot some class, but someone told me from the professors at the university that, for example, specifically linear algebra is very important.
It's super important, yeah. For quantum mechanics, you need to know linear algebra like the back of your hand.
Would you say that the I don't know if the question makes sense, but would you say that the pure mathematics is more important than the mechanics? It's like
look, so you're going. It's not that it's more important, because in some sense doing physics means that the physics part is the mechanics. But the point is that in order to be successful in a physics degree, it is highly recommended to make sure that you have strong mathematics background. Because otherwise, like, think of it this way. If you're trying to learn calculus at the same time that you're learning mechanics, then that means that you have to begin to understand two things at the same time rather than understanding one thing at the same time, or one thing at a time. And it's just harder. Like, it's harder to learn the mathematics at the same time that you're learning the science. So what I would say is that if you can, make sure that you kind of like get ahead of the program for whatever physics that you're going to do next. Not to say that the mathematics is more important than the physics, but that success would mean being comfortable with math, or success often means being comfortable with mathematics.
Yes. So that's ultimately the reason why I chose the conversion program. So I have one more year to like get more comfortable with the high school mathematics and physics. And so my last question, I guess, would be that if there is any, like, first I would like to say that I'm fairly comfortable with all the high school physics, like trigonometry and stuff that is usually being taught in high school. I'm pretty comfortable with that, but I'm like a little perfectionist, so I just wanted to take one more extra year just in case there is anything else I need to like go over again. And so I assume that I will have pretty like light schedule compared to as if I was in the second year of bachelor's, for example. And so I would like to start focusing on some like supplementary class, for example, like in my program, for example, like general topology or like Poinsett topology is not something that's included in the first 2 years or the first 3 years, I would say. And I was thinking maybe, or like it's more like a question, if it would be a good idea to maybe pick it up, assuming that I am very comfortable with the official curriculum first, and
no,
then
you won't be ready for Poinsett topology in your first year. You won't be ready for it. If it's anything like I tried to do the same thing. I was just like, Poinsett topology, the thing about it is it's not like calculus, it's not like linear algebra, it's not like differential equations where you're solving stuff. It is a different way of thinking, and unless you're, I mean, like, okay, maybe you're just built different, but like, I would imagine that most people who are not like mathematical prodigies wouldn't be ready for a topology course in their first year, because there's just a lot of mathematical maturity that you should develop beforehand.
So essentially, if just to make sure I understand correctly, so you would recommend only sticking to the official curriculum. I got the list from my university's website, and just to complete the list, it is Mechanics 1, Mathematical Methods in Physics, it's called. The basics of programming, linear algebra, and mathematics 1, which is basically the analysis 1. So that's really,
I mean, like,
go ahead.
Do as much as you can, but just keep in mind that, like, so for for the physics side of things, you don't really need the kind of proof-based courses like topology would be. You don't really need that. What you need to learn the physics is you need you need to be able to compute and follow computations easily. And so, like, it sounds like you might not even need to do, like, I don't know you, so maybe you do, but it sounds like you might not even need to do this whole business with, like, taking the catch-up course or the catch-up courses. But, you know, what you could do is you could go take other math classes as well that are, like you could take, like, a course on, you know, like, differential equations or something if you're comfortable with calculus, for example. But yeah, I mean, if you're not comfortable with some of these topics, then it might just be a light course load as you get comfortable with them, and then you can, you know, increase your course load.
Well, yeah, essentially, like in the educational system here in my country, it's like in high school we don't take any calculus whatsoever. So the calculus is purely university class, I would say. And it is usually it is done in the first year of the bachelor's program, which is standard length of the bachelor's program is 3 years. And this 4-year course that I'm taking is basically the first year is literally a speed course on all of the fundamentals of mathematics.
I wouldn't worry about having too light of a course load. If you're learning calculus for the first time, it's not going to be a light course load. So you will have plenty to do.
Yeah, that's what I thought. I just wanted to make sure, since it's like I understand that I can find all of this information on internet, but it's different to ask directly someone who's got a PhD in physics and mathematics.
Sure.
You know, so
I mean, it's going to differ from country to country, but that would be my advice. Dexter, I'm going to let you go.
Yes, thank you so much for your time.
Of course, take care. I'm just going to go turn on the fan really quick. It's warm. All right, let's answer some questions, and we'll bring up our next guest. Make sure I didn't miss any. From Space Lord of 75, thank you so much for the $5. When I took my physics course in the 90s, we talked about how stuff like turbulence were one of the big physics problems. Have we made progress? Progress has been made, but it's still an open question. Like fully settling the Navier-Stokes equation, like fully settling whether there's existence and uniqueness. It is more of a math problem. Like, it's not really a physics problem, although like effectively and efficiently solving the systems are still very complicated and still like really difficult to do. But it is still an open issue. This has not been resolved yet. And then we have a question from Wilday. Can you explain the mechanism of the Higgs field endowing particles with mass? It's not really a mechanism that really is going to have any intuition besides like this kind of standard pop science analogy. The pop science analogy is that you can think of the Higgs field. So the Higgs field, when it's empty, it doesn't have zero. It's not empty at zero. It's empty at some higher level of the field value. It's called a vacuum expectation value. And so you can think of it as kind of providing a sort of like space-time molasses. So like there is like a stuff that's just, it's, you know, it's not zero, so it's always there and it's always affecting things. And if particles interact with the Higgs field, they will interact with this stuff whether there's Higgs particles or not, because the Higgs field vacuum expectation value is non-zero. And so it's that interaction. You can kind of think of it like a space-time drag, or like having to, you know, like walking through molasses, you move more slowly. You can think of it sort of like that, and that's the kind of thing that gives it mass. It gives it more inertia, basically, because it's harder to get to move. But the actual mechanism is a little bit more complicated than that. But that's probably like the simplest analogy that I can offer. And what would be the effect of one of those mediums where the speed of light is different by direction? I don't remember what they're called but my prof mentioned them in electromagnetism. What would be the effect of one of those mediums? Is this? I don't know what the question means. What would be the effect of one of those mediums where the speed of light is different by direction? So there are things, they're anisotropic materials. And like in that case, light will travel at different speeds at different rates. And so you can get something called birefringence, for example, which is where light bends differently depending on what direction it's going in. From no taxation without re-migration, what is the actual microscopic structure of space-time according to quantum gravity? We don't know, because we don't know what the correct theory of quantum gravity is. Most of the topology I've done could be self-taught quickly from select parts of textbooks. The full course I did was more than I did. Yeah, I actually didn't do a full course. I did the same thing. I self-taught most of the stuff that I needed. Can you explain what iron stars are and what it would be like to be up close to one? Yeah, so the idea is that in the very, very distant future, you might have white dwarfs, tunnel, so like, you know, iron is the most stable of the elements. So it might be the case that like the carbon and oxygen and nitrogen that makes up white dwarfs, those particles, those atoms might fuse together at an extremely slow rate and eventually turn an entire star into iron or nickel in the very, very distant future. We're talking like 10 to the 10 to the 10 to the whatever years. And they would be cold. If you were up close to one, it would have extremely strong gravity because they'd be very, very dense and still very, very heavy. But there wouldn't be that much more to it than that. And how is iron the most stable element? So it's iron and nickel. They're both like, you know, in some sense, one isotope of nickel is technically more stable, but they're both basically the same. The idea is that if you try to add more particles to an iron nucleus, it costs energy. And if you try to remove particles from an iron nucleus, it costs energy. Basically, iron has the lowest amount of energy per particle in its nucleus. So, you know, when you fuse elements, or if you break elements apart above iron, then they will release energy. If you fuse elements together below iron, they will also release energy. Would they be dark or would they glow in any way? It depends on how hot they are. If it's been that long, though, they will be very cold, in which case they'll just be dark. They'll be very, very dark. All right, let's bring up Dingo. Hey, Dingo. How's it going?
What up, Blitz? I was wondering if you're familiar with someone called Math Theorem. He's posted you on it in his account.
Yes, he's I've talked with him once or twice, and it's been really rough for him every time.
Yeah, I just had a conversation with him. He's blocked me, and he said he's gonna post our conversation.
Yeah, he's a nobody. I wouldn't worry too much about it. He's a nobody, and he doesn't really understand much of anything. He actually came on to, so I was on a live stream with Ian, and Matt, his original name was Matt Davids. He came onto the live stream, and he started quizzing me about my own paper, and like arguing with me about my own paper, which he clearly didn't understand. So like, yeah, he's not worth paying attention to. Like, he's good. He's good content, though.
Well, yeah, like I do have the DMs just still there. I'm not deleting them because he's blocked me. But if he posts it, then I have everything there to prove that he was just.
His posts get no views.
To finish. But,
like, I wouldn't worry about it. Like, his posts have no views. Like, so.
No, I was just gonna ask you something about like
Sure.
the conversation with him, if that's fine.
Sure.
So one thing he pointed out, like the original claim he'd made, was that BGV proves finitude in the universe, which evidently is just trivially not the case. Like I gave him the paper, I gave him the works of it, which is solely that like we have null and time-like geodesics that are just past incomplete. That's fine, and that the nature of that past boundary is not kind of concluded under BGV theorem, right? And I proposed something of the sort of like CCC, of which is accommodated of BGV, right? Like there is no contention between BGV and CCC.
Yep.
And from there, he just kept going with, well, the evidence doesn't support CCC. And he went forth with, well, CCC can't accommodate the expansion. And he used redshift as an example. It can't accommodate CMB, and it can't accommodate big bang nucleosynthesis. All of which I said are false statements as far as I'm concerned.
Yeah,
BBN,
very
like,
false.
Like light element abundance, I'm not too familiar with how like.
Well, to be clear, lambda CDM also can't account for all of the light element abundance. So, like, you know,
lithium-7 problem.
Yeah, exactly.
Yeah, right. So yeah, no. So this is what I was giving him, and he just kind of went down this route of, well, lambda CDM made predictions, and then there were certain like evidences. I say like they were like evidences. I don't know if that's a word that were found, and they said, well, this is rather measurement issue, or it was just accommodated under lambda CDM. And I said, well, lambda CDM also accepts it, and measurement issues are not falsifications of the theorem itself. They are just, it made a prediction, and then we said, well, this measurement found to accommodate the prediction was just, in terms of its own, like maybe the apparatus itself was just not calibrated correctly, that's fine. But it never falsifies the view, because what like a science cares about in terms of theorems is falsification, right? It doesn't care about verification anymore.
Yeah. Well, I mean, you know, practically speaking, it cares about verification, but like, yeah, philosophically speaking, science is really about falsification. That's true.
Okay, so thank you. So this is like when he posts this video of me, he is going to get slam dunked with this. I'm going to spend an hour, 2 hours. I don't care if I'm working or studying. I'm making a video on this guy. I'm sitting there and I am bringing him belt to ass.
So, by the way, a better critique of BGV is that, as written, it is trivially true. Because as written,
you make assumptions.
Yeah. Well, no. I mean, it's not even that it makes assumptions. It's that the way that it defines the average expansion assumes the average expansion is finite into the past. Like, it doesn't allow for a past finite interval, right? You can go look at the formulation that they give originally, and they define it as an integral from A to B, where A and B are elements of the real line, and use that to define the average expansion. So they integrate from A to B of the the Hubble constant is. It's not a constant, but they integrate H with respect to dt, and then they divide. They divide by b minus a to get the average expansion. That's how they define it. But the point is they don't allow a or b to be they don't allow for those to be non-real numbers, so they don't allow you to take the limit as a or b go to infinity or negative infinity respectively. So they just assume that it has a past finite, that it's like past finite. Like it's literally like begging the question. And there's the paper by Davies and Eason, and a name that starts with an L points this out explicitly. And so then they say, okay, well, we can repair the theorem, but once you've repaired the theorem, it's once we've prepared the theorem so that it's no longer begging the question, it's strictly false. So it's just like it's just not true. It was only true because the original formulation is only true because, well, because the way that they defined the scale factor, or the expansion rate rather, was very specific, and it's not general at all. And B, it was true because they didn't allow for a finite past in the theorem, in the theorem statement. So it's just not a good argument. And so that's the kind of thing that I bring up when people bring up the BGV theorem, but he doesn't understand that because he doesn't actually know anything about physics. I think that he uses ChatGPT a lot, and then tries to use it to get arguments in favor of XYZ thing. But I don't think that I think he's like 18 or 19, so he doesn't actually know anything.
Oh, well, I could tell that by his voice messages. He spent the entire time insulting me, but I gave him an exact paper on this idea that I gave him a paper. I literally do not know the authors. It may be exactly what you were talking about, but there exists some geodesically complete GFRW spacetime.
Yep, that's the paper that I'm talking about.
Greater or equal to 0, meaning the BGV hypothesis appears.
In fact, they have one. They have one not only where it's greater than or equal to 0. They have one where it's greater than 0.
Really? Okay. Well, see,
yeah,
I need to see.
Yeah, it's in the same paper.
Because I just pulled it up in terms of just the abstract, and I was like, "What trivially you're wrong here."
Yeah. They give an explicit counterexample to the BGV theorem. So they have to repair the BGV theorem first, because the BGV theorem as written is ill-posed, right? It's not well defined in a general spacetime, right. Even a general FRW spacetime, right? It just doesn't H along what geodesic, right? It doesn't. How are you defining H? How are you defining the scale factor? Are you using tidal forces? What are you doing? So it's just not correct as written. It's kind of ill-posed. But once you've repaired it in a reasonable way to kind of represent what they were trying to represent, then it turns out that it's false, strictly.
Right. Okay. No, I appreciate you. I'll let you hop on to your next guest. But
yeah,
I'm looking forward to him posting me, because I'm gonna post everything I said to him.
Do it. Have a good time with it.
100%, brother. I appreciate you.
All right, take care. All right, I gotta drink some more water. The BGV theorem is the Borda-Guth-Vilenkin theorem. It's a theorem that creationists pull to say that, yes, this proves the universe had a beginning, which it doesn't. Sorry, before I continue, I just gotta double check something. Okay, cool. And then I can go back here. Okay, I will answer some more questions from chat, and then we will bring up our next guest. Is that Dingo Dingo? It is Dingo Dingo, yeah. Ian seems to attract a lot of the weird ones. I mean, I've talked to him too. He's been making the rounds trying to make these arguments and failing everywhere he goes. But don't worry about that. It's good content. Can you explain magnetic moments in quantum mechanics? So, I mean, magnetic moments, whether in quantum mechanics or not, these are the essentially the strength, and usually they're magnetic dipole moments, is what we're talking about. These are essentially, they tell you how, the magnetic dipole moment of something tells you how that something is going to respond to magnetic fields. That's all it's for. And so the magnetic moment, like, you know, electrons have magnetic dipole moments, protons have magnetic dipole moments, and so on. And so, and magnetic moments also have their own magnetic field. So the magnetic dipole moment of a proton, for example, can affect the motion of an electron because the electron also has a magnetic dipole moment. So they can kind of influence each other. So like, for example, two aligned magnetic fields are lower energy typically than two anti-aligned magnetic fields. So if the magnetic moment of the proton is up, then the magnetic moment of the electron also wants to be up. So it'll have lower energy. Are physical conformal transformations magic? Yes. Yes, they are. I already answered what the BGV theorem is. So is there a solution to the lithium-7 problem? Probably. We just haven't figured out what it is yet. How are they wrong twice at the same time? Easily. Do you ever use something like Microsoft Whiteboard? I think some of your points may be aided by simple diagrams. I sometimes draw diagrams, yeah, but I don't usually use Google, like Microsoft Whiteboard, no. All right, let me make sure I didn't miss any super chats, and we'll bring on our next guest. Fotoblivik. I don't know how to say that, but Fotoblivik, how's it going? You were on the show. Fotoblivik. Maybe it's Flat Black Vic.
Yes, that's exactly what it is.
Great. Flat Black Flick. How's it going?
Not too bad. And yourself?
I'm doing all right. What questions you got for me?
So, I was reading not that long ago, who knows, properties of light, right?
Mm-hmm.
So, they had a super cold, dense cloud of gas that they were able to stop like a beam of light inside of, basically pausing light's travel, correct?
Something like that. Or they slowed it down extremely slow. Yeah.
Okay, so my question is, if it's slowed down extremely slow inside of this cloud of ultra dense, ultra cold gas, how do you see it? If you know what I mean, like, would it be emitting something that you
eventually
could see?
It comes back out.
Okay, so it's just the delay that they're able to see.
Maybe we're using C in different ways, but the point is that they take like a laser, basically.
Or measure. How about?
They take like a laser. And then they fire like a pulse at this thing, and then however they arrange the rubidium atoms or whatever it might be, the rubidium gas cloud, it like interacts with the rubidium gas cloud. Nothing comes out, and then they do something to the rubidium gas cloud to let something come out. They like destabilize it in one way or another, and then the light comes out again afterwards. And so, like, they can measure the delay between when it should have arrived and when it did arrive, for example.
Okay, but that's what they're measuring is the delay. You don't.
I imagine so.
See,
yeah.
You know
I mean, this is a gas. This is like a
actually
microscopic gas cloud, so like you're not going to see it anyway.
Oh, I see. And then, or like other things. What was it like stop motion film of light traveling? You know what I mean? Where they film it, a trillion frames per second. So like. In my mind, if they're filming it and you're like, let's say at a 90 degree to its direction of travel, it would actually be further ahead than what you're seeing because the light from where it was would have to travel to you. So that's just like a shift, correct?
Yep. And it can make things look very weird. It can make it look like the light has jumped. Like if the light is going to the left and then bounces towards you, it can make it look like the light that's coming towards you might get to you much faster than it should. Because it's closer now.
Right, and that was the only time, and I was like, man, because wouldn't that seem to break, you know what I mean, relativistics? But okay, so there is a delay between when you see it traveling and where it physically is in space time.
Yeah.
Beautiful, that's great. Because it's so difficult to like when you have a question like that. I don't know physicists, you know what I mean?
Sure.
So I very much enjoy the fact that you do take questions on things like this. The physical reality that we live in is extremely weird, and a lot of it's not very intrinsic. So having an outlet such as yourself to maybe bounce these off of is absolutely fantastic, and I just want to say thank you.
Well, of course. Thanks for being here, Flat Black Vic. Always welcome.
Have a great day.
You too. I have to take a thing. Because it turns out that a leave is very helpful if you have persistent pain, which I don't like. Don't like having that. Let's bring up, I think I talked to Satnam recently, right? So I'm gonna let somebody else come up. Mac, how's it going?
Pretty good. A few questions I just want to clear up.
Yeah.
Can every interaction in physics be described as a change in relationship rather than an isolated object?
We don't describe interactions as isolated objects, so I don't know what the dichotomy that's being presented is here. I mean, generally, an interaction involves something like the transfer of momentum or the transmutation of a particle.
So fields, interactions, symmetries, and conservation laws are fundamentally relational.
Yeah, they tend to be. Well, fields are not fundamentally relational. To be clear, fields are not fundamentally relational. Right. Symmetries are, kind of by definition. You're relating prior to the transformation to after the transformation. Interactions are relational, kind of by definition. But go ahead, continue.
Okay. So what is invariant when the vocabulary of physics changes? For example, Newtonian mechanics, relativity, quantum mechanics, quantum field theory. The mathematics change, the models change, but every theory still depends on things like conservation, symmetry, interaction, boundary conditions, propagation, measurement. Those are operator families. Okay. So what relational process causes every fusion pathway to terminate at iron?
I don't know. What relational process? I mean, I kind of already described it. Right, there are preferred ground state, or there are ground states and there are non-ground states, and it turns out that iron is in some sense the ground state of the, in some sense, it's the ground state of the nucleon system, or of the nucleonic systems.
All right, so the answer involves energy relationship, right?
Yeah, energy is energy is a useful conserved quantity when talking about nuclear physics.
Okay, so fusion releases energy only while moving toward nuclei with greater binding energy per nucleon.
Yeah.
Around iron and nickel, that trend peaks. Beyond that point,
is there a question here?
Using heavier. Yeah. So these are questions I'm asking you. What calibration standard prevents a white dwarf from collapsing indefinitely?
I don't know what you mean by what calibration standard.
Okay. Now the let's see, electron.
What happens is that there are
gravity.
There are relevant
quantum mechanics.
The point is that there are relevant forces, you can call them forces if you want, between the, for lack of a better word, atoms that make up the white dwarf that prevent recollapse. There's a gravitational force trying to recollapse them, and then there's other forces preventing recollapse. And the point is the other forces are stronger. I don't know what you mean by what's the calibration.
Right. Okay, so let's say that propagation happens within a field. There's a universal standard calibration that all systems seem to witness.
I don't understand what that means.
Governs the relationships like a coupler. I know. My grammar is probably, I'm not using the right grammar in your language.
I don't know what you mean by calibration.
The proper word relationship grammar. Okay, how do you calibrate something? There's a reference point, right?
Yeah, sure.
So if I take a frequency,
what does that have to do with like quantum field interactions?
Well, quantum field interactions have a calibration standard universally. Biology,
quantum
physics,
fields are not
thermodynamics.
Quantum fields are not like measuring devices. I don't know what you mean by they have a calibration standard.
No, but there's okay. I'm gonna have to ponder on what I'm trying to relay grammatically, because what I've noticed is there's a universal grammar, relationship grammar within most disciplines, and I have verifiable witnesses that'll validate this statement. However, propagation begins at different levels, just like atoms propagate to form hydrogen. Depending on how many hydrogen atoms are made depends on the atom coupling, if I'm saying this right.
I'm not sure. Why
Okay,
don't you go ponder what you were saying, and you can come back another time, but like, I just don't follow what's going on. It seems like the way you're trying to propose is like some sort of universal theory or something, and this isn't the place for that.
No, it's a universal relational grammar.
Okay.
That can be expressed in different languages.
This isn't the place for that. This is not the place for you to propose your, your theory or your model or whatever it might be, right? I have some questions to answer, so let's answer some questions from the chat. What is the lithium-7 problem? So the lithium-7 problem is merely that if you take the standard model of cosmology, what you'll find is that it accurately predicts the amount of hydrogen in the universe. It predicts the amount of deuterium in the universe, which is hydrogen with an extra neutron. It accurately predicts the amount of helium in the nucleus, or in the universe. It does not accurately predict the amount of lithium-7 in the universe, which is weird, and we don't know why. The residue theorem is complex analysis is the closest thing I have seen to magic. True, me too. Residue theorem is magic, it's true. Polaritons mentioned? I wasn't going to mention polaritons. I love gluten. Gluten is delicious. Gluten is delicious. Where do we go to try to join a call? You can go to the Discord link here, or you can join on TikTok, either one. The thing is I will be very mad if I have celiac, because like I don't get sick. Like I have some tummy troubles here and there, but like not in any way that like makes me like feel bad, really. And so I'll just be mad if I have celiac if it's like essentially asymptomatic but reducing my nutrition. That'd be very, very bummer, because I like gluten. It's delicious. All right, let's bring up DM 3.1415. DM, how's it going? You gotta unmute yourself before you can say anything.
Yeah, sorry.
You're good.
And I know you might hear some echo. I don't have a mic here, but I was just wondering if you would be able to explain UNRWA radiation to me, specifically how, because I know that it's like if you're accelerating, you can see particles that are slightly hotter than they should be, and you end up with a slightly higher energy state, and it takes more energy to accelerate. But I'm wondering from a third-party perspective, where you don't see any of those particles, you do still agree on the temperature of the object, right?
This is actually contentious.
Oh, okay.
There are people who think that UNRWA radiation, and it's probably more fringe to think this at this point, but there are those who think that UNRWA radiation isn't real. And it's actually really hard to interpret what's going on, because if you want to do this properly, you have to actually model the detector that's detecting the thermal bath itself as a quantum system that's doing the accelerating, and that's really hard.
Yeah.
The only way that I would attempt to explain it, because I probably don't have a good non-technical way to explain it, but the reason why this happens is just that and I think you already said it, that the ground state for a quantum field in an accelerated or a non-inertial reference frame is going to be different than it is in an inertial reference frame. So that's why this is happening. That's the kind of the bare bones explanation, and then the actual details as to why it's hotter in one direction, colder in another direction, that gets more complicated.
Okay, but if let's just say that it does exist,
mm-hmm.
And we have a detector and it detects the thermal bath, and it ends up at a slightly higher temperature than it otherwise should, right? As a third-party observer, if I'm over here and I'm not moving, or I guess I'm never moving in my initial reference frame, right? But yeah, I'm not accelerating with the object, right? And I don't see the thermal bath, but I would still see, to my understanding, I would still see it at the slightly increased temperature that UNRWA would.
It's not, and to be clear, it's hard to say exactly, but it's not clear to me that the thing would actually increase its temperature. Rather, because it's colder behind it, right?
Yeah.
So but what is the case is that like if your device, for example, like clicked whenever it detected a photon of such and such energy, like more than such and such an energy, then both observers would agree on the amount of clicking that happened.
Okay.
And so the non-accelerating observer would have to have a different account for why that happened. And I read an account of this like 4 or 5 years ago as to like someone proposed like this is how you would account for this. I just don't remember the details. But there are papers on this that are trying to, you know, account for this in a more explicit way. It's just tricky because usually we don't think of the measuring device as part of the quantum system. But here we kind of have to treat it as part of the quantum system because, you know, this is a very quantum-y thing that's happening.
That makes sense. So they both would agree on the amount of clicks, but their reasoning for it would be different.
Right. And that's not so unusual. This is the kind of thing that happens in relativity a lot. So surely you've heard of the ladder passing through a barn thought experiment in relativity.
Yeah.
So like in that case, from the person who's at rest relative to the barn, the reason why the ladder fits is because the ladder shrinks. Because of length contraction. But from the ladder's perspective, the reason why it fits is because of relativity of simultaneity. In fact, the barn is actually shorter from the ladder's perspective, so the ladder can't fit. But the reason why, and so the ladder actually is never simultaneously in the barn, both ends. But the reason why they like these ideas basically, or these scenarios agree with each other is because of the relativity of simultaneity. So in relativity, it's often the case that there are different explanations for the same observed phenomena.
Okay, got it. I'm still very new to this, so it's hard to wrap my mind around it in an intuitive way. But
there's a lot of these things that don't have good intuition. That there just isn't, at least as far as I'm concerned, there's not a way to make good intuition there for a lot of these things.
Got it.
Which is unfortunate, but you know, go ahead.
Yeah. I just have one more smaller question. So I've been trying to read papers and stuff. Like I said, I'm still very new to this, and I've just at school, I've taken up through Calc 3, Diffie-Q, linear algebra and stuff, but I still struggle to understand a lot of the math behind it. Is there any like recommended things that I should make sure that I absolutely know? Like, there's a
depends
lot of
on what you want to read.
Okay. I mean, I'm trying to just give myself a brief introduction into GR, and I've read a bit into special relativity, and that I can kind of understand pretty well. Like the Lorentz transform is fine. But as well as like the relative simultaneity, world lines, and all of that. But when I get into some of the quantum stuff, especially like with eigen operator states, or what's it called, eigenstate?
That is technically linear algebra. It's just infinite dimensional linear algebra typically.
Got it.
So okay, so you've taken linear algebra, you said?
Yes, I have, but I guess I didn't pay attention.
No, I mean it's normal. So basically, for the more sophisticated QFT stuff, you will need functional analysis, which is like what happens if you take calculus and you combine it with linear algebra in a very complicated or in a very sophisticated way. It's like the calculus on functions rather than the calculus on like individual variables. And you know, it's linear algebra instead of linear algebra on, you know, columns where the columns are on like columns of numbers where you have like some, you know, you have a column of 6 numbers or something, and then you have a matrix transformation for that. It is instead of columns, you now have functions. And then you can apply linear operators to those functions, and you can talk about like self-adjointness of those linear operators and all these things. So this is to say, functional analysis is really the bedrock of quantum field theory and really quantum mechanics in general. For relativity, special general relativity, you need, so the foundations for general relativity is going to be differential equations, some partial differential equations, you know, calculus, linear algebra, those kinds of things. But then you just need to learn differential geometry. Differential geometry is what you get when you combine all of those things, and that's the foundation of GR. But once you have those topics, those kind of background math topics, you will probably do all right with an introductory GR book. A good one that I like to recommend is Space, Time, and Geometry by Sean Carroll. It's what I learned out of it, and it was quite good.
Okay.
And so it's quite doable for someone with like an undergraduate education, as long as your math is strong. So
Nice.
But be prepared to like struggle, because like the ideas are genuinely new, right? Like it's not like,
Yeah.
I mean, you know, they will try to, like in the book, it's you try to make them like as intuitive as you can and like link them to things that you understand, but the ideas are new.
Yeah. And I will say I do understand all of those math topics, like on a like just like diffie-q and the like multivariable stuff
Sure,
on a fundamental
sure.
level. But it's still not easy for me, so it still might be a limiting factor, at least in understanding intuitively.
Sure.
But thank you very much.
Yeah, of course. Thanks for being here.
Yeah, that was all my questions. So thank you.
All right, let me make sure I didn't miss any questions, and then I'll bring up another guest. Do people actually use the lithium thing as some kind of gotcha? I've had at least one person do that to me. Still here, just charging my phone up in case Ian goes live. Fair. Let's talk strange matter. As far as we know, nobody's detected strange matter. We can make strange matter in a particle collider, but it doesn't seem to be stable when we make it there. Does it over or underestimate lithium-7? I think, God, I can never remember. I think it, I'm trying to remember what the diagram looks like. I want to say it underestimates it by a factor of like 2, which is a lot. Yeah. All right, let's bring up Physicist. Physicist, how's it going?
Hello, Blitz.
Howdy. What questions you got for me?
I'm sorry for my broken English.
It's fine.
I'm very new in this page. I see that you're a physicist. That's really interesting for me. I'm personally a corporate finance guy, but I'm really interested in that physics and issues. And my question is that I know that the science currently doesn't know what was before the Big Bang, and we know that the Big Bang is not the ultimate beginning of the universe, right?
Well, we don't know that. That's the thing. We don't know that.
Yes. But there is some theories. What was the before Big Bang? I just personally want to know, what do you think about that? Like, what was before the Big Bang?
I don't have an opinion on it. Like I'm happy to like speculate on it in a professional sense, and so like I'll write papers about things like interesting ideas, but I don't actually like have any commitments to any of them.
Okay. And the second question, what do you think? What is the biggest unresolved problem right now in physics?
It depends on what your area is. In my field, what I'm most interested in, the thing that I think that's most important is figuring out what quantum gravity is.
Quantum gravity?
Yeah.
Okay. Thank you so much, Blitz. Have a nice day.
Have a good one. Man, God, the sinus pain is really killing me today. If you see me grimacing, that's why. That's why I just took in a leave. Because it really hurts. It hurts quite a lot. I'm just checking something really quick. Okay. All right, let's bring up another guest. Let's bring up R. Guess R's not coming up. Ethan, stop it. Stop it. By the way, if you guys want to ask questions, and there are still several hundred of you guys here watching, a few hundred on TikTok, a few hundred on YouTube. One sec, R. If you guys do want... Yeah, I can. Just give me one sec. If you guys want to ask questions, but you don't want to come up, you can do that. It's like $5 a month, and it helps support me. It helps support the channel, and you know, you get this extra perk of twice a week. You can ask questions and get your questions answered over text. R, what's up?
Hey, how's it going, man? It's honestly really cool to be here. I've been watching your TikTok for a little while now. Like I've caught it a few times on live, and honestly, I'm just excited to be able to talk to you a little bit.
Yeah, of course. What questions you got?
Okay, so I don't know how familiar you are with Alan Cohn's program on non-commutative geometry.
I'm not familiar at all with it.
Okay, it's something that like kind of recently caught my eye. I was like just browsing YouTube in one of those late night watches, and I ended up watching this like little hour-long, essentially like lesson from him on his little spiel on what non-commutative geometry is and his perspective. Sure. And honestly, it made me start thinking like, the more I dive into physics and just the entire, I guess, essence of what everything is, it sort of feels like there's like a common thread in certain ways, at least very often. Like things are sort of like I guess a sort of crappy encompassing statement would be, oftentimes I find that things are just like the eigendecomposition of some like self-adjoint operator on a relational structure or something like that. You know, it's like always
that's the kind of
Is it just, am I tweaking?
No. I mean, like I have the same kind of intuition that you have, that like there is something there. There is something that seems like more fundamental mathematically. Yes. That's like underlying this stuff. It's just really hard to put your hand on it and like, you know, 100%. It's hard to get it right.
Nuts.
I mean, that is like, that question is the kind of question that drives people to do physics, right? To do like the really foundational, fundamental physics stuff that some physicists do.
Huh. Okay, so maybe I'm actually onto something in exploring that kind of just domain in general, because in a way I don't know, it almost looks like it's screaming at me. You know what I mean? Like it's like everywhere I look, it's just the same similar kind of like, it's a very similar pattern. And then it just makes me think, like, is it really just relational that actually is the thing that really matters? Like, it's not really the things. It's like just the fact that they're in some structure of relation that causes them to, you know, have some cause and effect.
What you're getting at is relationalism. There is an issue. There is one particular issue with the relationalist worldview, which I like relationalism a lot, but it has one issue. It can't really explain what gravitational waves are. It can't really account for that. And the reason I said,
actually, I'll let you.
Wait, so do you know what I'm addressing? Do you know why I say that?
Sort of. Is it about the fact that like when you look at a wave as it evolves across time or something, it's like the wave itself is like changing across time, but in a way you can kind of think of it as like an evolution of the wave, just not necessarily as a function of time, but as in a sort of different state. Is that what it was about?
No. So roughly what I'm getting at is something like, if you take the relationalist view, then you would then the thing that you would want to say is that if there's like no matter or no like, you know, fundamental fields that are excited, then then there should be like nothing going on. And yet there are, at least in GR, there are ways that you can talk about spacetimes that have no matter in them and yet still have gravitational waves. So like that means that there is something doing the waving, right? There's something there, which seems like it's not just relational, is what I'm getting at.
That makes sense. That actually kind of brings me to a thought about, and this might be totally tangent to you, but maybe you see the connection here. But I was thinking about like specifically in regards to the trace sector in like GR and spin zero. Is it? Maybe I'm completely wrong here, but is it possible that like we might have it a little wrong? Like, what if gravity itself is a sort of like a function of the field, so to speak? Like it's I guess maybe a part of the trace, if you will. That might be a bad phrasing for it.
Yeah, I don't really know what you mean.
I guess what I'm saying is like, traditionally when you're looking at GR, I feel like oftentimes I've seen in like the derivation, there's like a spin zero trace that kind of just gets like tossed away in the derivation.
I mean, you don't really derive GR. What derivation are you talking about? GR is when you're off the app, by the way, I can't hear you.
Oh, I'm so sorry. I was just saying, do you mind if I try to find my my note real quick? Because I had like made a little highlight on my PDF on this.
Are you talking about like deriving GR from like the Einstein-Hamilton or the Einstein-Hamilton, Einstein-Hilbert, I'm sorry, Lagrangian?
Yes.
Is that where? Okay.
Yeah, from the Lagrangian, exactly.
Yeah. Okay, so you're talking about throwing away like like the variation of the metric in the trace direction.
Exactly.
Is that what you're talking about?
Yeah, yeah. Like, why do we throw it away? Is it not just possible that it's like a metric tensor?
I mean, the trace is a scalar, right?
Mm-hmm.
So like,
okay.
The point is that like if you have some metric, you don't want to vary the trace because the trace of the metric is supposed to be, well, okay. So you can vary the trace of the trace of the metric. That is fine, but it loses it won't preserve things like volume forms anymore, which is something that it's a gauge fixing condition if I remember correctly.
Huh. Okay, that actually kind of does make sense. So you in a way you lose your ability to scale across the various dimensions in a way.
Well, no, it's just like essentially a coordinate choice.
Huh. Okay, so this would be more akin to, I suppose, I mean maybe this is a poor similar example, but I guess like choosing quaternions instead of for example, some other form of coordinate frame relative to a body, essentially.
It would be more akin to, are you familiar with like electromagnetism, like the standard business with Maxwell? So have you heard of like Coulomb gauge and Lorentz gauge and like all these things?
Sounds very familiar.
So the point is that like if you have a like an electromagnetic field, you can always add some constant, say, to the electric potential, and it won't change the electromagnetic field. Similarly, you can add a field that's pure divergence. Sorry, a pure gradient field to the magnetic potential, magnetic vector potential, and it won't change the electromagnetic field at all. So the point is that you have to make a choice as to how you're going to describe your electromagnetic potential, your electromagnetic force potential, which includes the electric scalar potential and the magnetic vector potential. You have to make a choice to basically pick which gauge, basically when you're saying, okay, I'm not going to allow you to add constants anymore to the scalar potential, I'm not going to allow you to add pure gradients to the magnetic vector potential, etc. And that's similar to what you're doing when you fix the volume form, i.e. fix the trace for when you're doing the Einstein-Hilbert variation business.
Huh.
So it's essentially like there are freedoms, like you don't like there are coordinate transformations that you can do that don't actually change the underlying physics, but they do change the mathematical expression for the thing. And one of those freedoms, and you can kill one of those freedoms, you can make a gauge choice by fixing the volume form.
Okay, that makes sense.
By allowing the trace to be fixed.
Okay, so that it's sort of a coordinate decision then, effectively. Yeah. It's really what it comes down to is, in order to fix that down, you then no longer have the variation across your other. Okay, that makes. So if you were to go sort of like, I guess if we're running with the ball here, like if we were to run with that in a way where we try to fix an alternative gauge, right, and kept the actual metric tensor, what would be the other thing that gets fixed then?
You could fix you could fix it so that the divergence of the or like the double divergence of the variation is zero. Like you could just choose some other scalar degree of freedom to fix, and like you can do other things. It's just not particularly useful. It doesn't buy you much.
Copy. That makes sense. It's
like
just
you end up with the same field equations, right? Like you're gonna get the same place. Yeah.
That's fascinating, though. That is kind of like a pretty cool little feature that I don't know. It almost reminds me of relativity.
So it is relativity. This is exactly a feature of relativity, which makes it hard. Gauge fixing actually makes these kinds of solving these kinds of systems extraordinarily difficult, because there's an extra freedom there that is essentially makes things underdetermined. And you have to figure out how to properly determine them, which is just really a mess. It's actually been like a thorn in my heel for a project that I'm working on. It's a separate thing. It's related to a different gravitational action. But anyway, anything else you got for me?
Honestly, that was all. But thank you so much for your time, man. This was truly a pleasure to hear from you, and I honestly really enjoyed this. I feel like I came out with a lot of learning. So thank you. I hope I get to engage with you some other time in the future.
Sounds good. Thanks for being here, R. Take care.
Of course. Take care.
All right, let's answer some more questions. Yeah, so it's not, the sinus pain is localized specifically to my left cheek sinus under my eye, and it kind of spreads over to my jaw, which is very unpleasant. I would just love to sit and talk planets in space with Blitzy. Yeah, well, the thing is it's hard to make time for those kinds of things. And in some sense, that's sort of what these are supposed to be, but there are a lot of people who want my time, and I don't have enough time for everybody. Stinky Ethian with the $2, can you talk more about the things waving? Yeah, so like when you have a gravitational wave spacetime, in fact, there are some gravitational wave spacetimes that are called PP wave spacetimes. Don't worry about why they're called that, but the point is that you can have a spacetime that just has like gravitational plane waves traveling through it, and there's nothing else in the universe. And so like there is definitely a thing happening because the space-time curvature is non-zero and it's propagating. But it's hard to say, and like you could even talk about like the energy of the gravitational wave. These are things that are like well defined. It's hard to say what's doing the waving, right? I mean, like back in the day, 150 years ago or so, we were like, oh, well, what's doing the waving to cause light to be an electromagnetic wave? Like, what is the electromagnetic wave waving in? Well, now we say, it's waving in the electromagnetic field. And that's just a thing that exists. And so if you want to be a relativist, especially about like space-time, for example, and say that, oh, distances and durations, these are only relative things, they don't exist on their own. Well, then you have to say, okay, well, if there's no matter to define these distances and stuff like that, how can there be a wave in nothing at all, right? Like what's doing the waving? What's the thing that's wiggling? That's the tricky part. And Ethan also asks, can you pull GR from least action? You can, yeah, it comes from a least action principle in the Einstein-Hilbert action. Yeah, Shay, the R was talking about quaternions. You can think of them as like, just think of them as like a souped up version of imaginary numbers. From Kobe Vodka, hey Dr. Blitz, absolutely love your TikTok lives breaking down general relativity. Quick question though, if spacetime is just a smooth manifold, why do my headphones always tangle into discrete topological nightmare in my pocket? Well, it turns out in 3 spatial dimensions, knots can exist. But thank you for the message in sub-only mode, Kobe. Is it because, no, the tooth was probably exacerbated by the sinus stuff, actually, which is unfortunate. What was it that Minkowski helped Einstein with when he was formulating GR? I don't know the details of the history stuff. I do know that he was the first to think of space and time as being like one part of a larger thing. All right, let's bring up another guest. Bam Noor, how's it going?
Hello, I'm good. How are you?
I'm doing all right.
Yeah.
I appreciate it. What questions you got for me?
Yes, I earlier heard you say you were interested in how gravity, quantum gravity.
Yeah, I am.
So I have a verse in the Quran because I'm a Muslim.
This isn't the place for that.
Yeah,
we're talking scientific stuff here.
Yeah, because there is also scientific things in the Quran mentioned. That's why.
I know that that's the position. This isn't the place for it. I'm gonna let you go. Okay. Thanks for being here, Famnor. All right, let's bring up Key Mud. Wait, come back. Key Mud, how's it going?
Hi, how's it going? I'm doing great. What about you?
I'm doing all right. What questions you got for me?
So the part where you talked about the relational structure.
Yeah. What about it?
And that you know, to define relational to mean just like relations between matter, it has to be like you know, when there's no matter, there's waves. How can it happen? So what if I think this can be responded to by saying that maybe the geometric degrees of freedom can be used instead of matter, so that you define them relationally, but making degrees of freedom geometric. You know what I mean?
Sure. I mean, you can do that. You can say that, well, like, the geometric degrees of freedom are the things that have relationships between them, and maybe that's the case, but then it just says that the geometric degrees of freedom are things that actually exist, and so you may as well have a gravitational, or you may as well have a space-time, because those are what kind of define the geometric degrees of freedom. And then the space-time is just a thing that exists rather than just being relational.
No, it is relational, but relation to the observer. You know that relational quantum mechanics defines everything to the observer. We can define the observer as being a subset of space-time itself, in this sense. And then you have
I don't see how. So, do you have any questions for me about, like, because I mean, like, speculating is fine, but like that's not what today is for.
Now the question is, do you think that like it was this actually, is this incompatible with general relativity, that you define you define it relational in this sense? Like, is it still a problem if you define it relational, but with respect to a subset of space-time?
It's just not what people mean by relational. That's all.
I mean, you know, relational quantum mechanics in terms of Rovelli's
that's not the sense of relational that's being used here. This is a branch of philosophy. It's relational versus not substantialism. It's a relationalist view versus a realist view.
Oh, it's instead of making it like absolute, we make it relational to a wave function or to an observer.
I mean, you could do that, but then you probably need a quantum theory of gravity.
Yeah, but that's what I'm saying, is that the relational structure might be compatible. It's not out of the blue, or like it's not outright incompatible with general relativity, like in this sense.
Maybe, but you need some sort of theory of quantum gravity. But we don't have that yet. All I'm saying is, look, I'm not making the claim that this is like a killer for like relational views. All I'm saying is that this is a common objection that's used, and it doesn't seem like that there's a good explanation for what it would mean for space-time to not exist and to only be defined relationally if you can have gravitational wave spacetimes. That's all I'm saying.
All right. So another question. Can I?
Yeah, go ahead.
You? All right. So what do you think of operator time in the sense of
Never
making
heard of
an
it.
operator? There's like yeah. So it's
is
exactly
this like a formalism?
Yeah, it's the Pauli objection and whatnot, and there's things like it's basically trying to make time like space and make it also an operator with states, eigenstates and so on.
I haven't seen this formalism. Like I can understand the idea that you're getting at, but I haven't seen the formalism, so I don't really have an opinion on it.
All right. Okay. No problem. Thank you very much.
Of course. Thanks for being here, Keymod. Just know I was with you on the Europa over Mercury. Appreciate you. Yeah, right? Mercury can suck it. How do large stellar bodies form? No, but actually we should just mine Europa. How do large stellar bodies form? I guess like cosmic webs or something. What causes them to arrange the way they do? The idea is that fundamentally there are tiny fluctuations in the early universe, and those kind of seed gravitate. Those are like those act as like gravitational seeds for structures to coalesce around. Boundless Gleam says, seems unconstructive to refuse scientific idea or contribution because of how someone came to it. Look, I'm just familiar with all of the claims that are made. Like, I've had that conversation 100 times, and it's not helpful, right? The observer effect is one of the most confusing names in physics. I agree. It is absolutely confusing. Why can't we cross the streams per Ghostbuster? Well, you can. You can cross the streams. Just got to figure out a way to do it. Y'all, I am going to end the live stream here. My jaw hurts and I need coffee, and I'm hungry, so I am upsetty spaghetti, if you will. So I'm going to end the live here, but that means I will be live tomorrow for some more debates. I will also be making a special appearance on somebody's live stream tomorrow evening, so make sure to stop on by to the debates tomorrow. Make sure to stop on by tomorrow evening. I'll give you more information about it when I get it. Take care, everybody, and thank you so much for watching. Remember, if you want to ask your questions during the subscriber-only chats, make sure to become a subscriber. It's only $5 a month, and it really helps me a lot. So I will see you guys next time.